Hi, once again, a very good morning to all our guests today. May I once again invite all our guests to please come into the ballroom and be seated as well, as we are expecting our guest of honor, Ms. Lo Yen Ling, Minister of State, Ministry of Culture, Community and Youth, and Ministry of Trade and Industry. She will be arriving very shortly. So right now, my sincere apologies to be interrupting your conversation this morning, but I'd like to invite all guests to be seated right now. Thank you so much for your cooperation. Later on, we're going to have breaks and lunch, and we definitely going to have chance to do more networking as well. And right now, I would also like to bring your attention to the screens beside the stage. As you can see, and I'm not sure if you're familiar with Slido, but of course, if you're here with us yearly, we have been using Slido, the app, to do our Q&A segment. So if you haven't have a Slido app, I would like to encourage you to bring our phones out, and you can scan the QR code, or please feel free to search Slido, S-L-I-D-O. All right, SLIDO, and that will help to facilitate the Q&A later on. So as the speaker speaks, you have questions, feel free to type into the Slido app at any point of time during the presentation. And after the presentation, we are going to do a Q&A, and this is where the app will come in very handy. So once again, ladies and gentlemen, right now, I would like to encourage you to scan the QR code or download Slido that will help to facilitate the Q&A segment later on. And also, ladies and gentlemen, we are really excited this morning. Have a great catch-up networking with business partners and new partners as well. We'd like to encourage all guests to be seated right now, as we are expecting our guest of honor to come in very, very shortly. Thank you so much. Hi everyone, may I grab your attention please, and I will need all our guests to be seated at this point of time, as our minister will be coming in shortly. At any moment actually, so I'd like to invite our guests to be seated. Thank you. All right, ladies and gentlemen, let us give a round of applause to welcome guest of honor, Ms. Lo Yen Ling, Minister of State, Ministry of Culture, Community and Youth, and Ministry of Trade and Industry. Ms. Lo is here with us in the ballroom. Ladies and gentlemen, shall we give her a warm round of applause, please? Thank you so much, Ms. Lo, for gracing this year's conference. It's great to have you here with us this morning. Really appreciate it. Thank you, everyone. Ladies and gentlemen, may I invite you to be seated, and we're going to kickstart today's conference. And greetings to everyone. Once again, thank you for joining us at the SSIA Semiconductor Business Connect 2023. I'm Paige. It's an honor to be your MC for this event. Indeed, an honor to see everyone this morning. Once again, thank you, Ms. Lo, for gracing this year's conference. Thank you so much. And I would also like to take this chance to extend our thanks to sponsors and supporting partners for supporting this year's event. And this year's speaker and exhibitors look at tackling the challenges of digitalisation, automation, additive manufacturing, and sustainability. It is also the first time we have invited partners from various agencies and a US embassy who will be holding advisory clinics later today for companies that are interested in initiatives to help their companies innovate and grow. So ladies and gentlemen, let's kickstart the day and invite SSIA Executive Director Mr. Ang Wee Sing on stage to give us his opening speech. Wee Sing, please.
Ms. Lo Yen Ling, Minister of State for Ministry of Culture, Community and Youth, Ministry of Trade and Industry, industry leaders, partners, and friends. A very good morning to everyone. Now, I welcome you all to this year's Semiconductor Business Connect, where we discuss the latest and greatest trend of our industry, but most importantly is to encourage business connection, business matching, and networking. I'm really encouraged and happy to see how this platform has grew over the past years. And this year, there are more companies participating than ever before. This year's event will also introduce a new, very relevant and important topic for our industry, and that's on sustainability. Now, the chips manufacturing does create a huge carbon footprint, and this will have a significant impact to our so-called environment. On the other hand, the semiconductor is also required to power technologies that will basically drive and support the global climate goals, things like electric vehicle and solar panel. So this kind of creates a paradox between what the industry can achieve and what they should achieve for both businesses and also the environment. Now, in the other words, this can also be seen as a huge opportunity for our companies to engage solution providers in this space and together to lead the way in creating a more sustainable industry. So I hope today's event will really help companies identify these opportunities and really to establish partnerships and collaboration towards a common goal of sustainability. This year also marks a monumental milestone of 55 years for our Singapore semiconductor industry. SSIA, with support from our good friend, the Economic Development Board, EDB, will be organizing a landmark celebration for the industry on the 19th of September. This is the week right after Singapore Formula One Grand Prix. We will celebrate our past achievements, the accomplishment that we have made over the last few years, but most importantly, the future of our industry here in Singapore. The Singapore Semiconductor 55 dinner will be held at Resorts World Sentosa for 1,500 guests. This will be our industry's largest physical dinner to date, and I hope to see everyone there at the dinner. Now also, by virtue of the 55th anniversary, it is important that the semicon industry companies continue to give back to the community. We will feature a charity art auction at the Semiconductor 55 dinner, and this is in partnership with the Northeast CDC to raise funds for the special needs community. Now this, to me, I hope will have strong support from the companies for this very good deed. I will share more information in the coming weeks on how we're going to do this auction. Yeah? Now, in conclusion, I would like to take this opportunity to thank all our sponsors and partners for their continued support to make Semiconductor Business Connect a success. Your support not only helps bring this event to reality every year, but it also helps fund SSIA operations to support and strengthen and grow the local ecosystem. So I look forward to connecting with all of you at the networking session. So please stay on to the end of this event where we'll have a round of beer together. Thank you.
Thank you so much, Wee Sing. It's really looking forward to the celebration in September to see all of you gather together once again. All right, ladies and gentlemen, right now, shall we put our hands together to welcome Ms. Loh Yen Ling, Minister of State, Ministry of Culture, Community and Youth, and Ministry of Trade and Industry to give us the opening speech. Ms. Loh, please.
Thank you so much, Wee Sing, for the opening speech, and very happy to see many familiar faces. Why so? Because I was just telling Brian and Wee Sing that when I received this invitation, even though it's in the midst of a very hectic 4 days parliament sitting, I said I must be here for the semiconductor sector because this is a critical and strategic sector for Singapore. And number two, I spent 10 years in EDB. I was just telling the friends at these 3 tables. That was, okay, anyway, my age is public information, so I'm quite fine to share that. I was in EDB from 2001 to 2011, and I remember spending the first 5 years of my 1 decade of service in EDB with, doing a lot of partnership with semiconductor industry. How many of you will be familiar with this term called Local Industry Upgrading Program, LIUP? I see Alwin there, all my EDB alumni. LIUP was a very important program that EDB started as we bring to Singapore all the greenfield projects, semiconductor, etc. Because even as we bring the companies here, we provide the LIUP support, which is at a point in time $100,000, a significant amount of money, to sort of second the MNC headcount, such that this headcount from the MNCs can work with our local suppliers to facilitate knowledge transfer, then eventually sort of technology transfer, etc. This is really industry development. This is really cluster development. And I'm very happy to be here at this important event for the sector to see a very thriving and vibrant ecosystem. So a very good morning to Mr. Brian Tan, Vice Chairman of Singapore Semiconductor Industry Association, SSIA. Very good morning, Wee Sing, good speech. And ladies and gentlemen, it is my pleasure to be here with you at the Semiconductor Business Connect 2023. I think you will agree with me, and many of you are veterans in the industries. I was just chatting with the youth in the white shirt and the black pants. She is a Singapore Polytechnic student. Kudos to all our youth working for today's event. They are the future for our industry, right? So it's really great to see a combination of veterans, youth, business leaders, MNCs, SMEs coming together. I think you will agree with me. 2023 marks a milestone of 55 years for Singapore's semiconductor industry. And I remember, Alwyn, can you stand up? This is my EDB colleague. I didn't know he'll be here. If my eyesight a bit better, I can hunt more. He was involved in a lot of cluster and market work. And we remember that our journey with the semiconductor sector in the 60s started when Fairchild, ST Microelectronics, Texas Instrument, ring a bell, and National Semiconductors set up assembly and test plants here. A&T, front end, back end. And in 5.5 decades, Singapore have grown in importance in the global semiconductor supply chain. We now, as a small little red dot, as a small nation, we now account for about 5% of the global wafer capacity. 5% is not small if you think about, the entire global market pie. And our companies, over the past 55 years, have also successfully moved up the value chain in their operations with the adoption of state-of-the-art and best-in-class manufacturing technologies. Notably, our electronics sector, of which semiconductor sector forms a major component, has consistently been the largest contributor to growth for manufacturing sector. I was telling Brian and the EXCO of SSIA that Singapore government and MTI were very clear. Manufacturing sector will continue to be a key sector for our GDP, and minimally 20%, right? And manufacturing, of course, we know that part of manufacturing is electronics, and key component of electronics in semiconductor. Now, in year 2022, the electronics sector generated 65 billion Sing dollar in value add, accounting for more than 40% of the total value added of our manufacturing sector. With more than 61,000 workers employed in this sector, we expect to create more than 2,700 jobs in the next 3 to 5 years. Now, yes, today, while the semicon sector is experiencing softening demand, I think we can come together today in this conference to acknowledge that there is room for optimism, especially with exciting developments in artificial intelligence, electrification, we're just talking about EV, etc., and 5G communications. Semiconductor is in all the devices that we're carrying. Is in our everyday life, is what powers our life. The global semicon industry is likely to continue growing in the medium to longer term, and is certainly on track to cross the $1 trillion sales mark by the end of this decade. So against this encouraging backdrop, Singapore is well placed to capture new growth opportunities. Now I come here even though later on I have to dash to Parliament because I want to join you in this forum today to share with you that the government will certainly continue to partner with industry players, including yourself, to build capabilities and drive growth in the sector, and pressed on with the strategies that's being mapped out in the refreshed Electronics Industry Transformation Map ITM that was launched in October last year. Now, coming back to what Wee Sing mentioned, the theme for today's event is strengthening the ecosystem with emerging technologies. To be honest, this has always been the playbook for the semicon industry, right? Future-proofing yourself, make sure that you're always pioneering the next wave of emerging technology. And this is very much in line with the Electronics ITM, which aims to support industry growth through R&D. The electronics sector and the semicon industry in particular will need continuous and sustained investment in emerging technologies and R&D. So recognizing this, the Singapore government has set aside 25 billion Sing dollars over 5 years under the RIE Research, Innovation and Enterprise budget to bolster public-private research efforts to help companies invest in emerging technologies. Now we welcome you to bring this information back to your HQ in your home countries or back to your senior management as you think of the next R&D project. Consider partnering any of our A-Star Research Institute to facilitate and to consider, catalyzing some of these efforts through the RIE. We have also launched the Future of Microelectronics initiative, which identify 5 research pillars for our medium to longer term focus: heterogeneous integration, future communications, novel architecture for Edge AI, wide bandgap semiconductors, and piezoelectric MEMS. Now, amongst the many R&D areas that companies are delving into, we talk about it, sustainability has certainly become a growing area of interest. I'm very happy to note that my colleague Kai-On, where are you, Kai-On? I think you're somewhere in the room. Kai-On will be taking to the stage later to share more about Singapore Green Plan 2030. Why is it important? I think you know that many consumers are increasingly demanding net zero supply chain, and several key semiconductor MNCs have announced ambitious net zero targets. So I would like to use today's platform to encourage all our key industry leaders and local companies to pursue sustainability and innovate in the green space, which will certainly give you an added competitive edge. Now, can I have a show of hands? Don't be shy, and it's not a trick question. How many of you are here representing multinational corporation, MNC, Micron, etc.? Okay, put down your hand. How many of you are here representing local company? Okay, quite a good representation. I say this because now I'm going to turn to the SMEs. I hope you will find out a little bit more about the $180 million Enterprise Sustainability Program, ESP, that MTI relaunched in October 2021. Now, this is a major program that we launched that is aimed to supporting our own local SMEs to embark on your sustainability journey. And we take an enterprise centricity approach, sectorial-centric approach, and an ecosystem approach. Now, allow me 2 minutes just to share very briefly with you, because I think it is important because many of the SMEs could be suppliers and could be partners in co-developing products and projects with the MNC. And this is where we want to level up all the players in the semiconductor industry in terms of your sustainability quotient. So when I talk about enterprise centricity for the $180 million Enterprise Sustainability Program, now think of it this way. For the SMEs, and I think for semicon SMEs, you're quite advanced in your game. But even if your SMEs not quite sure where to start, think of it this way. Think of it as Enterprise 101. What we can do is we can use the grant to support you and your company and your staff in embarking on knowledge sharing webinars, etc. To that end, we can get Enterprise Singapore to work with SSIA to curate webinars, conference like this that's very customized for semiconductor. I think today is a teaser. So this is an example of how some of the SMEs and your team of staff can immediately really, up their knowledge and skills about sustainability. Then, what is Enterprise 201? Many of the companies will know if you incorporate sustainability in your business processes, actually it will help you to maximize resource efficiency, operational efficiency. So companies can certainly, SMEs can tap on the Enterprise Sustainability Program for that. And in some cases, some companies, SMEs have already incorporated sustainability into their products and services. That's Enterprise 301. You can use the ESP program for this purpose. So the way to think about enterprise-centric approach to tapping the $180 million grant is 101, 201, 301. So then what is sectorial? I like to talk about sectorial here because this is where I think SSIA can play the role of a multiplier. by working with Enterprise Singapore, potentially tapping on an LEAD grant or even Enterprise Sustainability Program to embark on, say, a multi-year sustainability work plan for the industry. You can decide, you want to focus on maybe the lower hanging fruit, whether is it reporting, auditing, governance, etc. And then, work with Enterprise Singapore or the industries to curate and to aggregate the partners accordingly. And you can tap on the grant to do so. So that's sectorial approach by tapping on the grant. What is ecosystem? We all know grants aside, actually we need certification, we need training, we need green financing. And this is why after we launched a $180 million Enterprise Sustainability Program, we also started working with local banks, foreign banks on green financing. Sunsip, which is it is a local company, of course they did some merger. They solarized a lot of our public housing rooftop. So they secured $85.8 million of green loans. Dura Power, a very promising local company in energy storage system, they secured also about $8 million of green loans. So we facilitate and we catalyze green loans as part of that ecosystem approach. So because today's theme is really about sustainability, I wanted to share more. So to the SMEs, please do check this out. So I'm also very happy to hear that SSIA has taken the first bold step to mobilize efforts at an ecosystem level. And I know that you're convening a sustainability committee with representatives from the industry that's tasked to reduce the sector's energy, water, and carbon footprint. And I want to applaud SSIA on your efforts because events such as today's Semiconductor Business Connect really play a critical role in boosting the industry network and connections. I came as early as about 8:30 and I saw a lot of, hobnobbing outside. And I think it's wonderful to feel that energy is very palpable because after 3 years of COVID, I think it really makes a lot of difference. Firm handshake, and exchanging ideas and inking deals, from today's conference. And in fact, Semiconductor Business Connect, I know this is the 5th edition and you have grown from strength to strength. It offers an ideal platform for companies to explore partnership, collaboration, and innovation. The SSIA will not only continue to play a key part in connecting our semiconductor companies to solution providers, but also in maintaining strong overseas industry network. We are really starting to see promising outcome for these efforts. Now, I'm a strong champion of local companies, so allow me a couple of minutes to highlight a few local companies. I'm not sure if you're with us. If you're with us today in the room, if I call out your company's name, just give a wave. I won't make you stand up. Now, companies such as Innovate Tech, are you here? Companies, they are here. Wonderful, thank you. Companies such as Innovate Tech, they have been able to link up with and provide solutions for semiconductor company, right? Very proud of companies like Innovate Tech. And through SSIA's network, Enterprise Singapore has introduced companies in emerging technologies like additive manufacturing and 3D printing into the sector. Now, it is game-changing for Semicon. Why? Because with additive manufacturing and 3D printing, the presence of these enterprises actually provide us a good alternative to securing obsolete semiconductor equipment parts, right? Actually, it really allows us to future-proof our industry. And local companies which provide 3D printing services like Create 3D, are you here? And ELH Tech, they have been able to also meet the semiconductor industry needs in this area. So I hope you use today's platform to make more friends, exchange ideas, and push the boundary. I want to thank SSIA's team for working very hard because they have also recently worked with Enterprise Singapore to lead a mission trip to Arizona to learn from the industry experts from Intel, TSMC, and Lucid Motors. Now, all these mission trips are important because it allows us to learn best practices from the semiconductor plants in US. And I really would like to encourage you, now that the COVID measures are all lifted, please continue to actively participate in such overseas trip to broaden your overseas network and learn best practices. We also hope to see many more fruitful collaborations between companies in the wider Semicon value chain. Now, I want to sum up very quickly. I want to use this platform to assure you that the Singapore government is strongly committed to growing our semiconductor industry. As I've said, manufacturing sector is a key sector for Singapore economy, and of which electronic sector is very important, as we all know, and we will continue to work closely with the companies and industry associations such as SSIA to facilitate knowledge exchange like today and to strengthen our ecosystem. Just as the complex and intricate circuits in the semiconductor chips are all interlinked to work well together, I think this analogy works very well for semicon. And I say that because I spent a lot of time working with all the IC company back then, the front end, then subsequently the back end, applied materials as well. So just as the complex and intricate circuits in a semiconductor chip are all interlinked to work well together, I think this ecosystem, semicon ecosystem, is especially special. Why? Earlier on, I was chatting with some of you, and I'm going to call out Kok Sing, right? Kok Sing, can you stand up? Sorry, give a wave. I think he's one of the veterans in the room. I won't disclose his age. And the two ladies, can I invite you to stand up? I won't disclose your age as well. They started from Tech Semicon, right? And he was their mentor. And the both of them graduated and are now key management in their respective company. Such is the magic of the Singapore semiconductor sector, that you create and you incubate talents, and talents graduate to move to other company, but actually the whole is more than sum of the various parts. And I think we really punch above our weights. So every company and player in the semiconductor sector, big and small, play a part in the growth and success of this highly connected industry. So I hope all of you will leverage today's conference and event to strengthen and expand your circuit of industry connections. And I wish you all the very best and abundant opportunities to grow your business and form fruitful partnership. Thank you, thank you, thank you.
A big thank you to Ms. Low as well. Thank you for all your sharing and updates, and also taking time to join us this morning despite your busy schedule. Speaking about sustainability, ladies and gentlemen, our first speaker today will be sharing on the government's plan to achieve net zero emissions by 2050, to grow the green economy, and to partner industry players in the transition to a sustainable future. Kai On was appointed Director, Industry Division, Climate Change and Sustainability in the Ministry of Trade and Industry in June 2023. He oversees the development of strategies for Singapore to decarbonize our industries and grow the green economy. So, ladies and gentlemen, please join me in welcoming Mr. Kai On, Industry Division, Climate Change and Sustainability, Ministry of Trade and Industry. Welcome.
Thank you. Good morning, Ms. Low Yen Ling, Minister of State, Ministry of Trade and Industry, and I would say fellow ex-EDB alumni. Mr. Brian Tan, Vice Chairman of Singapore Semiconductor Industry Association, and Mr. Ang Wee Sing, SSIA, Executive Director, and ladies and gentlemen in the audience. Good morning. It's a great pleasure for me to be with you here today, this morning, to join you in Semiconductor Business Connect. I must say I'm less familiar with this industry, but because of my previous experience in EDB, definitely in the know of how important this sector is. The semiconductor industry is an important part of the Singapore manufacturing sector. It makes up 70% of our GDP. And earlier on, Ms. Low shared briefly about how the industry has transformed since the 1960s. Yep. And indeed, our achievements today could not have been possible with many of you here in the room, whether you're from a multinational, a local company, a foreign investor, or from a very important trade association. And all of you here saw the opportunity to grow and to develop this industry over these past 50 or so years. But looking ahead, there are many challenges as well as opportunities before us, and I think that same amount of foresight and perseverance that you have shown in the past many years will be brought to bear again. And of course, chief amongst this growing opportunity as well as challenge is the growing expectation for sustainability, and in this case, environmental sustainability. And today I'd like to spend a few minutes sharing with you about the government's role in driving sustainable efforts in our transition to a much lower carbon future. So for an island country like Singapore, which is also very low-lying, we are small and we only contribute 0.1% of global emissions today. However, we are nonetheless committed to doing our part for global climate action, lest we disappear under the sea. So we have set an ambitious target of reaching net zero emissions by 2050. It is an ambitious target, and it would require all of us to come on board, all sectors of society as well as industry, to bring us to that target. And part of that effort is enshrined in the Singapore Green Plan 2030, which we launched 2 years ago, and it sets out a whole-of-government approach and whole of nation approach to trying to attain sustainability targets and agenda. And this green plan covers a few facets. First amongst them, city in a nature, green economy, resilient future, sustainable living, green government, and of course, energy reset. So on that last topic, the transition to a low-carbon energy source is a key aspect of our climate commitments. Currently, the power sector contributes about 40% of Singapore's carbon emissions. And of course, behind the power sector are people like you and me, the power users, both residential as well as industrial. And decarbonizing this power sector is thus crucial to Singapore meeting our net zero goals, as well as providing companies, which you represent here, with reliable access to cleaner energy. The government is adopting a multi-pronged approach and strategy to this energy transition, and to this response to this energy transition. First and foremost, solar. Solar remains Singapore's most promising source of renewable energy. We do get a lot of sun, and that's why we sweat a lot as well. We do as much as possible to maximize solar deployment and use energy storage systems to manage solar intermittency. This includes novel solar deployments such as floating solar. You might see them as you jog along some of our reservoirs here in Singapore, as well as solar farms on Tengah Reservoir, which at 45 hectares is one of the largest floating PV systems in the world today. Beyond deployment, we are continuing to invest in R&D and demonstration projects to try to push the envelope of technology and making it commercializable, both here in Singapore and for the rest of the world. So these would include things like high-efficiency solar PV, test beds for building attached PVs, as well as moving from reservoir and now to open sea floating PVs. To meet future increased electricity demand and our climate commitments, Singapore will also bring in large-scale power imports at the scale of about 4 gigawatts by 2035. And under the Energy Market Authority, EMA, request for proposal, we are happy to update that we have received 20 proposals to supply electricity from sources from other regions, and these power sources stem from solar, wind, hydroelectricity, and geothermal. So in March this year, EMA issued a conditional approval for Singapore's Keppel Energy to import up to 1 gigawatt of hydropower, solar, and potentially wind power from Cambodia. This is the company Royal Group Power Company. So I encourage semiconductor companies here to please reach out to importers to discuss potential collaborations to support these electricity import projects and to discuss your future power needs in a low-carbon future. So beyond these two ongoing efforts on the energy transition part, we will also need to leverage emerging technologies to fully decarbonize our grid. And so last year, we launched our national hydrogen strategy to develop hydrogen as a major decarbonization pathway. These are much longer plans, but they're very important. We are embarking on Pathfinder projects to deploy advanced hydrogen technologies and have also recently closed our expression of interest to the public for ammonia power generation and maritime bunkering. Ammonia as a hydrogen carrier. We will also invest 129 million in R&D under phase 2 of our low carbon energy research funding initiative. And this is meant to improve the techno-economic viability of some of these low carbon technologies like hydrogen and ammonia. And of course, our goal is to support businesses in accessing renewable energy. That is primarily why we are doing all these 3 initiatives, is to give that optionality as you and allow companies here to expand your renewable energy portfolio. So even as the government ramps up the supply of renewable energy, it is imperative for all companies to become more energy efficient, reduce carbon emissions, and green their operations, just to remain competitive in this new future before us. And we are heartened to see companies in the semiconductor sector setting very ambitious goals. Companies have set net zero goals and have embarked on innovative initiatives to use less energy and to reduce your Scope 2 emissions. I can call up a few examples. ST Microelectronics, together with SP Group, deploying their largest industrial district cooling system by 2025, as well as innovative process improvements carried out by GlobalFoundries, which allows them to switch to chemical rinsing with cold water as opposed to hot deionized water. Again, that should result in some lowering of energy use. So we are mindful that the transition to low-carbon future may lead to increased cost for companies. However, in that same vein, we hope that it would also lead to long-term increases in efficiency and lower emissions, and of course, lower energy bills, because you use less of it. The government will continue to support businesses in the green transition. For example, EDB's ongoing Resource Efficiency Grant for Emissions, REG-E for short, co-funds up to 50% of cost for emissions reduction projects by large manufacturing companies. Yeah, and this would include efforts in energy efficiency, as well as non-CO2 greenhouse gases. So we understand that already today, some semiconductor companies are in close conversations and discussions with EDB on potential projects, and we encourage more companies to reach out to my colleagues at EDB. I think just now, Ms. Loh also mentioned about the Enterprise Sustainability Program, and in terms of sectors as well as themes. And some of these themes bear repeating. These are topics in decarbonization and sustainable finance, and we hope and we expect 6,000 enterprises to benefit from this particular program from now to 2025. The successful transformation of business operations will require a lot of innovation and willingness to test out new solutions. And here, the government will continue to support businesses in developing greener solutions. For example, in November last year, we launched the Green Economy Regulatory Initiative, GERI for short, and that's to encourage innovation by reducing red tape, regulatory barriers for businesses in the green economy. So under this program, agencies will work together with businesses with approved proposals to scope out regulatory sandboxes for their projects on an expedited timeline. So we welcome businesses to submit proposals for these innovations related to sustainability, and these proposals not only include energy, but optimizing of water, energy usage, and of course, emissions. They should also be significantly different from existing solutions in the market, which is why we wanted to set aside a regulatory sandbox to begin with. And we hope to be able to help you in your innovation journey. So interested companies, please come forward, apply online to MTI's GERI website, or reach out to MTI's Pro Enterprise panel for more information. So I would like to encourage all companies to tap on these schemes that I've mentioned earlier in my sharing to increase your energy efficiency and reduce emissions. And if you have innovative carbonization solutions in mind, please do not hesitate to reach out to my colleagues here at MTI or at EDB. To conclude, the journey to net zero is one that requires the collective effort, and this is clearly something that we see here today within the semicon ecosystem. The government remains committed to supporting the semiconductor industry in the transition to this low-carbon future. We also encourage companies to come together to jointly develop and implement decarbonization solutions. I think many of the lower-hanging fruits have all been plucked, and the technology, innovation, and business ingenuity of this ecosystem must come to bear. And of course, we definitely see this today in the spirit of Business Connect 2023. So by tapping on each company's strengths, we will be able to collectively navigate the energy transition and capture new opportunities in a low-carbon future. And I think every company and every one of us play an essential role on this journey. So with that, I wish all of you today a fruitful discussion during this afternoon's breakout session on sustainability. And I actually look forward to learning about the innovation, the initiatives, and all the new partnerships that you're hopefully going to forge this afternoon during this conference. Have a good conference. Thank you.
Thank you so much, Kyle, for sharing the trends on sustainability. All right, touching on sustainability as a kickstart, our next few speakers will explore trends in the areas of manufacturing, starting with Mr. Koh Chun Yap of Soitec. Chun Yap currently heads the production and supply chain operations in Soitec Singapore Microelectronics Private Limited, with 23 years of experience in the industry. He will be presenting on the interconnectivity of sustainability and lights out manufacturing and innovation 4.0. Let us give him a big hand, please. Mr. Koh.
Morning. Morning, Ms. Loh Yen Ling, Minister of State. Morning, Wee Sing, Executive Director, SSIA. Distinguished guests, ladies and gentlemen. It's really a pleasure for me to speak at this event today. I'm not a familiar faces during his speeches. Actually, this is one of the 5 field that I'm speaking right now. That's why I'm really appreciative of this. Before I start, Soitec actually is not I would say not a common name in the semiconductor industry. So I would like to take this opportunity also to talk a bit more about the company before we begin on our topic today, sustainability and lights out manufacturing. Soitec is actually a France company headquartered in Grenoble, France. Actually, it's a global leader in engineered substrates, and we have more than 2,000 employees worldwide, with manufacturing plants over 4 countries. Okay, and actually, we hold more than 4,000 patents currently. In this case, just last year alone, we have more than 300 generated, and actually. We spend quite a bit of amount of our revenue, sizable amount of our revenue in research and development. So actually, where are we in the supply chain for Soitec? We are actually in a very niche position between the bulk suppliers and the equipment makers in this case. So we are tightly connected to the downstream of the value chain, where we do talk to our the end customers, and this is where we get valuable feedback, not only direct from the foundries in this case, and to make our products we aim to make our products a standard, industry standard, by this process. Yep. Okay, and this is where there is this first link of the company to sustainability. In the context of global warming, actually the depletion of our natural resources and the loss of biodiversity, our planet is currently facing threats of unprecedented intensity. So businesses like us, we have a part to play in overcoming these threats. This is what drives us on a daily basis to innovate and to surpass ourselves in order to better reconcile electronic performances and energy efficiency in electronic devices to build a more environmental friendly future. Okay, with this actually in apologies. How do I go back up on the slide? Sorry. Okay. With this actually in 2021, we launched our corporate responsibility policy with a roadmap running through 2026. So what we have here is, in terms of material, we are actually saving 10 times the material in terms of wafers by reusing our own wafers in this case. Yep. And also, in terms of carbon footprint, in the Paris Agreement, actually in Scope 1 and Scope 2, we have actually committed to reduce 25% of our emissions, but at the same time, doubling our volumes by 2026. So this is really I would say is a challenging, but we are already on our way to achieve this in terms of our targets for emissions. Yep, and in terms of our end products, actually by design ourselves for Cytek's products, we are already in the sustainability phase. So how we engineered and how we design our products, what comes out of it is actually already complementing what we have in what comes out of the wafers. So for SOI products, silicon on insulator products, we have the end products are energy efficient. In terms of low power products, we use 25% lower, 40% lower consumption in low power products in this case as well. Okay, and this is where already in our design phase and the innovation phase, we can be considered at the start of the wafer manufacturing. We are already getting to be energy efficient in this case. Okay. In terms of our manufacturing capacity, we are having both fab expansions right now in France and Singapore. So actually we have the honor of having Ms. Loh at the groundbreaking ceremony last year at Pasir Ris in this case. And also in France, we are completing our fab for silicon carbide manufacturing for this. So actually with all the manufacturing capacity online, it's going to be an impressive 5 million wafers a year for all wafer sizes, for all types of engineered substrates, gallium nitride, silicon carbide, silicon on insulator, etc. Once all the fabs are fully online in about 1.5 years time in this case. This is Cytek's financial year 25. Okay. So in Pasir Ris itself, this is crucial for the group's total output capacity. We aim, actually, if you look at the graphs on the left, we aim to ramp up in 2 years and double the volume by 10 times what we are currently producing for Pasir Ris. This is together with Vienna 3. Vienna 3 is a piezo on insulator manufacturing plant in Vienna. But if we just focus locally, it's going to be a huge, huge ramp for the fab here in Singapore. Okay. So back to the main topic on lights out manufacturing. So this one is a very, I would say, in-trend topic. We hear about this often, but what do we understand about lights out manufacturing? So different people have a different interpretation of it, but actually for us, lights out manufacturing is actually the full automation of the production line. So can we really off the lights in the clean room, in the production shop floor, and carry on our production? Before we have an answer on that, let us just take one step back and look at the bigger picture in this case, which is Industry 4.0, the enabler for this. Okay. For Industry 4.0, on a corporate basis, Soitec has actually taken some steps actions and steps towards its roadmaps to achieve this. So one of the main initiatives for the fabs in this case, so this is, we have a 6-inch, 8-inch, and 12-inch fabs. One of the main ones is, of course, automation in this case. We are trying to deploy more automation, more robotics, and also more remote access from the fab. So by what we mean by remote access is that we try to bring the processes from the shop floor out to the office in this case, or a control room in these aspects. So this is what we built for both France and Singapore in terms of infrastructure and readiness. Okay, and also for the quality-wise, what we call augmented quality in this case, we do have the most of the fabs down here. We have the advanced SPCs. We have smart samplings in this case, and we have AIs. We have AIs meaning defect recognition, etc. But again, it's how we do it in each individual company catered to our specific processes that we need to manufacture our wafers inside. So, and coupled with this, we also have the supply chain. We did implement some new business apps this year for customer relationship management, for S2Ps in this case as well. We had our SCM in this year. This is our financial year. And also, right now, both fabs are undergoing a piloting of the MES, that means improvement of the MES in terms of a digital twin, advanced scheduling, advanced dispatching in this case. So I'll say we're on its way on a corporate basis, but just to share on a local basis, what is Singapore doing for the current fab over here? So for Singapore, actually to go towards our aim of a lights out, we do employ the 6 M's over here. Yeah, you will see an unfamiliar word on the right. This is the French word for environment for this. So they need to come together to make what we mentioned about a fully automated shop floor work for this. So I just go through each one briefly. For the man, which is always, because I'm primarily a production guy, for the man is always the most important factor that we need to consider. When we upscale the technologies inside the fab, when everything becomes automated, what happens to the people inside the shop floor? So this is one, especially in the case of a full fab, a fab which is full in terms of capacity. You employ all the people in, and where do they go after this? So this is in terms of the manpower upscaling, uptasking that we need to do, and really we need to consider when we undergo this process. It's not an easy process because the people, most of the people in the fabs are operator levels in this case. And this is where we need to convince and we need to have a very structured way to upskill them and deploy them to other areas. Okay. And machines, this is a standard, advanced PM, automation, and we go these through steps. There are manual tasks that we need to do. We spend the effort to automate these processes. Smart PMs, the system tells you when the tool is due for PM. We do not go by schedules. We go by instead actual performances, and they tell you when the time is right for PM. They automatically down the tool for PM in this case, preventive and maintenance, as I mean. Okay. For material-wise, as I mentioned, we have already deployed the digital twin in the factory, and this is a step already towards the advanced scheduling and dispatching that we are currently doing right now. And also this gives us the chance, in this case, to do in a way further than what the human brain can think every day. Right now, the system reacts really instantaneously to tell you that, okay, this is the correct plan. It runs a few multiple plans a day just to tell you that which is the best plan to move the wafers inside the line. Okay. And the rest, I'll say, methods, measurement are pretty standard. And the one that I want to talk a bit more will be the last one on the environment in this case. And this is where I'll share in terms of examples what we have done, a bit more in detail, what we have done on the environment, especially on the facility side. So for the fab, I mean, couldn't take more in because of confidentiality, but for the facility side, this one definitely, yeah, I'll go a bit more on this, okay? So on the topic again on lights out, can we do a lights out? I would say definitely yes, but depends on company to company and how we structure our process and manufacturing in this case. We may not fully turn off lights for certain industries, but we can be very close to that. In the end, this is what I say in the beginning. We aim to be fully automated in this case. This is what we want to do when we strive towards this goal. So on the facility side, what the facilities guys has done on our plant here, they have fully digitalized the information from facilities onto onto a digital platform in this case. So in terms of the data, the sensors that the facilities have and everything, is all into software, and this gives us a chance to optimize the settings, the facilities we are using every day on the energy to produce the wafers. So what has this resulted in? Actually, we have improved 20%, over 20% kilowatt per wafer in terms of the energy use over the baseline that we used to have. So this coupled with hardware that they put in, the energy efficient chillers, etc., and all that, we are actually, I'm proud on behalf of the company to say that in this year we have achieved the ISO 50001 certification for the company. So it just shows that the results are showing, and what we need to do is to put in initiatives that is required based on the manufacturing process. So we don't need to take the full scale of a whole package of what is available on the market. We just take those that is just relevant and put it to a to get the most efficient results in this case. Okay. And And with this on the sustainable portion, what we are running here locally, we also have this chance to put it on a greenfield plant in this case, which is what we are currently building, the new extension of Pasir Ris. For this, we have put in thoughts and in terms of design, and this is where, for the new building, we look at it from a design point of view to have the aim of achieving the platinum grade for the building. Okay. And through passive design, reducing heat gain and green wall, etc. Of course, solar is a norm right now. We have solar panels on the rooftop. And hardware, as I mentioned, the chiller plant, the higher efficiency chiller plant, etc. And digitalisation. In this case, this is from the current to bring over to the new plant. And this is in a step towards to get the certification needed for this new building. So pretty again, this is on track. Pretty confident that all will go as planned in this case. So yep. And for my last slide, actually, I will want to talk about something not relating to my main topic over here. Okay. If we look at the last slides, the last 4 squares, in this case, the water efficiency, energy efficiency, and others, they are pretty much what all the companies are doing. But I want to focus on the first square. So in this era of industrialization, in this era of AIs coming in, etc., we should not forget about the man factor. So when we built our greenfield, we built our new plant, we wanted the place to be one where the employees come in and be happy at work and treat the plant as a home. So this is something that I also want to share in terms of this climate right now. The industry is getting more and more automated, but again, in the very end, we should not forget that the human factor is still one of the most important one that we should take up, because we are the ones that are in control of all this. Okay? Yep. Thank you.
Thank you so much, Chun Yap, for your sharing. All right.
Is there any questions?
Any questions? So far, there's no questions from the Slido. Any questions to answer? There's no questions from the Slido. We just last checked. Okay, but I'm sure they can catch you later on very shortly during the break and during the lunch. Thank you once again. Shall we give another big hands to Chun Yap? Appreciate your sharing. All right, yes, we are coming to our first break of the day, but before that, please allow me to share that in partnership with SSIA for Semiconductor Business Connect 2023, Go Net Zero is sponsoring renewable energy certificates, RECs, to all attendees. So right here to participate, you can scan the QR code at the back of the small little booklet that you have on the table. There's a just flip to the back, there's a QR code. You can just scan and fill the details, and we'll retire an amount of RECs equivalent to the annual electricity usage of an average Singapore household. But of course, if you would like to find out more, you can head over to Semcar booth right outside for more information. All right, I shall not hold you up, ladies and gentlemen. Let's go for a short break, and let's all be back at 10:10 a.m. sharp for the next segment of the conference. Thank you so much, and see you later at 10:10 a.m. Thank you. All right, moving on to the realm of AI, we now have Dr. Pamela Lin, Senior Manager Data Scientist at Infineon Technologies. Pamela will touch on AI trends and technologies in semiconductor manufacturing, focusing on back-end processes. She will also talk about how AI can be embedded across all business functions to support manufacturing from supply chain to sales and marketing. So ladies and gentlemen, a gentle reminder, you can still use the Slido app for questions later on. And right now, shall we invite Pamela to speak on AI in sustainable manufacturing and beyond. Pamela, please.
Good morning to all. So my name is Pamela, and I'm a senior data scientist, senior manager data scientist from Infineon. So today I'm honored to be here, invited by SSIA to share with you the latest trend in AI and how it contributes to sustainable manufacturing and beyond. Before I start, next slide, please. Before I start, I would like to give a quick background about what Infineon Singapore is. Yeah. So basically, you can just finish the animation. Yeah, so we are the regional headquarters for functions across the value chain and also advanced backend test manufacturing and innovation side. So recently, we are awarded as the AI hub for Infineon, as well as the Industry 4.0 Lighthouse by the World Economic Forum. Since 2022, we are actually on our journey towards advanced automation. So for the past 3 to 4 years, we have explored, experimented, failed fast, and learned about what AI can do for us. So now we are actually moving forward to be more focusing on how to make AI more operationalized, to actually then translate those AI abstract ideas into really implementable solutions that make business sense for us and can really reflect in our cost saving. So here I am today, not really to tell you what AI applications we have in the backend semiconductor manufacturing, but where we are moving next with AI. So for a start, I would like to maybe share with you the overview of the back-end manufacturing process. So basically, when the wafer comes up for the fabrication plant, it undergoes a series of assembly process to become a chip, and then we will subject it to different test insertions to ensure its reliability and quality. And of course, depends on the level of quality. If after each critical process, we usually have some metrology equipment to measure the quality of the product, or even automated optical inspection to look at the visual defects before shipping them out to our customer. So, yeah. So for those terminology, I guess like some of you guys are familiar with this I 4.0 terminology, like big data, analytics, IoT, digital twin, AI, etc., etc. And they still remain very much valid. However, as our AI maturity increases, we want things to be better, to be faster. So for instance, instead of sending data out to our cloud, processing it, and then returning back to the machines to make real-time decision making, in process, this actually incurs certain risks, such as missing data transfer, and also high latency, right? So as we learn more about what AI can do for us, we want things to be faster and better. So we actually look at focusing more towards edge AI that can actually help us deploy model at the machine level to help us with some real-time analytics. So another frequent, I think Katrina also shared that a lot of application involves like replacing certain process to optimize them. So one of which that is more widely employed will be like virtual metrology, virtual testing. And because of this, quality is actually very high priority as our concern, right? So how do we actually make AI more explainable to our stakeholders? So meaning that stakeholders during the development process, stakeholders usually ask us, how does your AI comes to this decision? So, and explainability actually is extremely crucial when quality is of concern, and there are many different ways that we can do it. So for instance, if we are talking about parametric process optimization AI, we usually show them the different features important, what AI actually rely on to make decision. And as a result, these outcomes are usually quite coherent to the process understanding by the process engineer and the quality engineer. And even in the event when it's not, we actually use statistical like data distribution means to actually explain how the AI makes this decision. And coming to applications such as defect classification, where you have images, the problem that we have in developing such solution is that we usually have underkill and overkill, which means that sometimes the AI will allow escapee and also over-rejection by AI. So using experimental AI, meaning that we visualize all this to them, allow them to see how the model capture which features in the images to make a certain decision. And sometimes when they actually look at all these ambiguous reject images and subject to different operator, they also know that different operators will make different decisions, right? So sometimes these are like new insights gained for them. So as we shift towards Industry 5.0, where humans work alongside robot and AI, I think autonomous material handling is becoming increasingly popular, and its intelligence to maneuver around the shop floor is also powered by AI. Okay, so I would like to illustrate how all these new technology are coming in together to make our shop floor more highly intelligent and automated. And I'm going to use the example from the wire bond process. So as you see over here, we have a factory line of the wire bond process where you have your machine lines up back to back. And in the middle of it, next slide. Can you click for me, please? Yeah, in the middle of it, we have the RGV, we call it Rail Guided Vehicle, to transport the material, to replace human to transport the material within the process. And on the outskirts of it, we have this autonomous mobile robot, we call it AMR, and often it is coupled with some robotic arm to actually load and unload material across the processes, right? And given this highly automated process, you can imagine the amount of digital data that is going to be generated. And especially in wire bonding process, if you are familiar with it, every wire bonder is a trace data generator. And imagine that if you need to really make decision at real time, you really need to employ HAI to actually make decision quickly. So as mentioned, some of the applications is like virtual metrology, where we replace the physical metrology test to ensure that we still produce a good product, and also anomaly detection, right? So all these are done, but we need to be able to explain them to our stakeholders. And because of that, we still have certain one or two metrology tools to actually validate those results. And not all solutions actually require real-time analytics. So things like if you want to do process optimization by detecting shift in your process performance, then you want to analyze them to later on go control back to ensure better process stability, or even making your equipment more efficient with predictive maintenance. All this does not need real-time analytics. So we still require some form of cloud solution to do such AI. So last but not least, sorry, the previous slide. We still make use of digital twin to run millions of different scenarios to ensure 4M synchronization, and also our operation to be as optimized at all time. And also all these are not possible without the IoT integration. So this is what, how AI can actually contribute to our next level of operation. And imagine, next slide, please. Imagine we can actually scale this across all our different backend processes, like the molding, the die attach, the testing, and then scale this across all our global sites. In Infineon, we have more than 6 backend manufacturing sites. The benefit will multiply to help us achieve towards sustainable manufacturing. So in this case, I'm not going to illustrate about all the applications that we have, but I want to focus on the main 3 contributing applications in semicon that we apply that contributes to sustainable manufacturing. So first is actually defect classification. I think many of you guys are familiar with it. So basically, we are replacing human judgment. We are making our AOI, automated optical inspection machine, more intelligent by using AI. And in the process of doing so, we actually reduces machine stoppages. Why is there machine stoppages? Because at some point, if your machine is not intelligent enough to judge whether to pass or fail the image, we have AI to take over, right? They will actually stop and ask operator to make the judgment. And because of AI, we can replace this process and make it more efficient. So therefore, it contributes to energy efficiency. And also on top of that, sometimes operator may make certain error, the machine, because of its configuration, rule-based configuration, it may cause over-rejection. And with AI, it's made more intelligent, and this will actually improve our scrap due to over-rejection. And in the second application, I think it's widely mentioned, popularly used as well, is the virtual metrology. It's like replacing, using AI to replace your physical measurement. And even sometimes we know that metrology tools can be destructive in nature, for example, such as the shear test, the pull test, where we test the reliability of our wire bonding. So by doing so, we are actually skimming process. We are actually we don't need so many metrology tools anymore. And in this process, we are actually reducing processing step in backend, and that will definitely contribute to energy efficiency. And on top of that, as mentioned, some of these metrology tools are destructive in nature, so we are actually destructing good products. And by not doing so, we are saving scrap again. And lastly, of course, there is predictive maintenance, but I do not use the word predictive here and intelligent because we do not want to limit ourselves to just predictive maintenance, because maintenance itself, there are many different types of strategy, including conditional based, which do not really require AI, but more like advanced data analytics, whereby we put different data together, machine, product, transactional data, to help our line prioritize their maintenance activity. And in the process, we use AI to recommend what tools to repair or to replace. And because of that, we can actually shorten the maintenance step and also reduce the downtime. And we also know that sometimes machine stability may also cause over-rejection of our product. And hence, by rectifying them earlier in advance, we stop the bleed, and therefore we reduce the over-rejection by equipment as well. Okay, so I think enough for manufacturing. I would like to also share with you how Infineon embeds AI across all business functions beyond manufacturing using this 5-step approach. So basically, to do AI, it really all starts with awareness, and it does not only depends on a small group of experts like us, but to involve the entire organization as well. And this is how Infineon does it. So we have the first step whereby we create the infrastructure, digital infrastructure, for example, providing an open cloud platform, data accessibility to everyone for them to explore and experiment with AI to create the awareness. Secondly, we also talk about digitally transform and drive change. And in this case, we really focus on upskilling and reskilling of our employees. And we partner closely with government institutions like EDB, local educational institutions like Red Dragon, AI Singapore, our local university, NTU, NUS, to curate a training landscape that actually caters to different learning needs. For example, people who just want to know what AI can do for me, or people who want to upskill themselves to become a business analyst, to become a data scientist. We even provide formal training such as master's and PhD program to support them in this. And on top of that, moving along with AI, we create new job functions such as data steward to govern the quality of data. We have AI project management, which is a special type of project management. So we also bring courses like this to actually upskill our employees who want to pivot from the jobs that are already obsolete. Yeah. And with all the awareness and knowledge that we help our employees to go through this entire process, the next step will be brainstorming for ideas. So we actually organize like AI ideation workshop in every business function to actually help individual to think about what AI can do for them. How can it change their way of doing things? How can it make them more productive, more efficient, right? And through this, we have good ideas with good value, and then we actually implement them. And with all the successful project, of course, we need to share them, and that's where we have our communication team coming in to organize roadshow, talks, and even build small community for different groups of people with different level of understanding of AI, so that it creates a safe environment for them to share and change knowledge. And of course, not forgetting our ecosystem. We build strong partnerships, not just with the institutions that I mentioned earlier, but we also work with a startup and external consultancy to actually help us accelerate our AI journey. So one noteworthy activity that recently we did was non-business related. We organized an autonomous car racing competition within Infineon using, so small group of people, they will come using machine learning, they will train their car to be faster, yeah. So after 3 years of effort, next slide please, yeah. So we have about almost 40 AI projects running across the whole value chain, ranging from design center, our central functions like legal and HR, and sales and marketing, and even supply chain. So my key takeaway message over here is that AI starts with awareness, and we need to focus about enabling our people, not just hiring the right expert. We need to get everyone to be involved in this AI journey for it to be successful. Next slide, please. Okay, so this is my final slide. So AI, when we talk about it, it's all about data, right? So you must make data available, you must have the right quality data, and so on and so forth. People talk about data, data, data. But what I want to mention here is about the right data. So we can have enormous and huge volume of data from the manufacturing processes, but we need to have the right data that contains pattern whereby the AI can learn. So if you have data that can't even describe your problem, and then your management say, hey, you have all the data here, can you do something about this? So that's not really possible. And secondly, we know that data actually generates from a system and processes, but I think one form of data that is often missing is actually the data from people, right? So what I mean by this is, for instance, maintenance, right? We have machine data signals, we have alarms, we have user logs, but this will only tell us what problem happened, but it doesn't tell us how the problem can be solved and why the problem happened. And all this knowledge actually resides in our shop floor personnel. And it's very important for us to digitalize all this knowledge for AI to learn and recommend. And thirdly, to achieve equipment stability and process stability, we need to work very closely with our equipment supplier now, not just for buying high-tech equipment, but also for software, more intelligent software. So basically, why do we have to work together? Okay, so basically, we are the process owner, we have the process issue, and equipment vendors are the one with the accessibility to the equipment data. However, even though they know their data, equipment inside out, but they don't govern how we run our data. So a lot of time when we evaluate external solution, vendors, when they try to provide us with solution, many of the times their solutions are not effective in addressing our problems. So there's a lot of time we need to work together to collaborate in this sense. Right, and of course, lastly, is about setting up the right organization structure to support this change. So having the right expert, yes, AI expert, so maybe you say you want to have 50 data scientists, but data scientist is not the only role in AI. We need to handle some operational topic, like do we have enough digital translator, like our business analyst that can talk from our data scientist language to our domain expert. We need this sort of people. We also need AI project management role, which we realize that is a different role, different scope to a normal project management. So we need to actually pivot along the way, right? So AI, so my end message here, AI in sustainable manufacturing is not a single small group of experts, but it's a collective effort from each and every one of us. Thank you.
Thank you, Pablo, for your presentation. Please hold on. We do have a question for you on Slido. The question is, considering sustainability, any suggestion how AI can be used to improve towards net zero?
Okay, so as I mentioned before, so AI can, there are three main applications AI can do in manufacturing. So process optimization, intelligent maintenance, and defect classification. So net zero means that we try to reduce the carbon emission in a sense in back-end manufacturing, right? So as I mentioned earlier, some of the AI application is about reducing the amount of process step, reducing the need to go through certain quality check and buying certain quality metrology tool. So by reducing all this, we actually do not need to go through this process, and in return, we are actually consuming less energy, right? And because Infineon prioritize quality view quality as a very high priority, right? So a lot of time we have very stringent quality standard that even though it's not a customer requirement, we still have these criteria that will cause the product to go through to scrap the product. So using AI, we can actually for example, virtual testing, right? So we actually skip some of these tests that usually induce higher yield by making sure that other processors can actually say that this product is stable and is of good quality. I think Katrina also mentioned something similar. So that will actually reduce our waste. And I think in supply chain, they also have some projects that also look at lifespan storage of our product, because demand and supply is always varying, and it's really difficult to forecast. So a lot of time we store our products in inventory, and when they are expired, they actually just have to scrap them. So using more visibility and more like dashboarding and things like that, they can actually look at what are the inventory that have high risk of scrap, and actually try to salvage them by finding customers to buy it, or whether there are ways to actually rework them. Yeah, so these are different methods that different initiatives that we have, that we are working towards net zero using AI. Yeah.
Thank you so much for sharing. Any other questions? We do have a little bit of time for one more question, perhaps. Else we'll probably keep the questions for the panel discussion. So Pamela, please remain on stage. Shall we also give Pamela a big hand once again for her presentation? I would like to invite you to take a seat on the panel as well as we move on to the panel discussion. So yes, Pamela's presentation actually leads into our panel discussion on the topic on strengthening the semiconductor ecosystem with AI, artificial intelligence. Oh, all right, let's invite up the moderator and other panelists on stage to discuss the topic. We have moderator, Mr. Jan Nicholas, Executive Director, Deloitte Consulting. Panelists, we have Mr. Sim Kim Seong, Managing Director, Applied Materials, Fadvantage Consulting Group Asia. And back on stage, we have Ms. Katrina Westreek, Global Head of Vertical Management, Semiconductor Digital Industry, Siemens AG, and as well as Mr. Ko. Mr. Ko Chun Yap, Director, Production and Supply Chain Ops, Soitec. All right, indeed, with the recent advancement and hype on AI, enabled by the big data analytics and machine learning. So how will these impact our semiconductor industry, and how it can strengthen the semiconductor ecosystem? So without further ado, I'll hand over the time to the moderator, Mr. Jan, and this is the iPad for the questions. So yes, feel free to keep your questions coming into the Slido app, and here you go. Enjoy.
Thank you very much, and thank you everyone for joining us today. As mentioned, my name is Jan Nicholas. I lead Deloitte's semiconductor consulting business here in Southeast Asia. I'd like to have each of the panelists introduce themselves very briefly. Some of them you already know.
Yeah, maybe just really short. Katarina Westrich, I'm heading the vertical management in Siemens for semiconductor. Have worked before in research and pre-development, also in integrated circuits, electronics, power electronics, also sustainability, and 10 years with Siemens now.
Yeah, so I just shared. So my name is Pamela. I'm from Infineon, and I'm a senior manager data scientist.
Yeah, my name is Kim Seong. I'm working for Applied Material, AGS. I'd also like to recognize some veterans in this room, like Kok Seng, Brian, and also Gyok Hong. I think without them showing me the ropes or motivating me along the way on the semiconductor, I wouldn't be here today. Yeah, thank you.
Hi, my name is Chun Yap, currently heading production and supply chain in Soitec. Spent about 13 years right now, total in service in Soitec. Yeah.
Okay, great. You guys ready for the first question? All right, so we've talked quite a bit about AI this morning. One thing that's in the news a lot that we haven't touched on is you're constantly hearing the hype around large language models, around ChatGPT, around the impact not only on the semiconductor industry from a volume perspective and from a share price perspective, but also people hypothesizing how large language models and ChatGPT might impact different industries. And my question to start out with is this all hype? Is there a role for large language models in the semiconductor industry, or is it mostly going to be around AI and ML for manufacturing and productivity efficiency? What do you see as the impact, and what do you see around the hype for ChatGPT? So I think for the first question, Pamela, you wanted to take a shot at this one.
Okay. I think we have started AI ML exploration and experiment, as I mentioned, 3 to 4 years ago, even before the birth of ChatGPT, right? And we have applied it in many different ways that really help us achieve the next level of productivity. So now with ChatGPT, what else can we do more, right? So I would foresee in the next 1 or 2 years, we will see more application in the natural language processing, especially in the business supporting functions, whereby they do a lot of service providing. So for instance, I mean, this is what we had done previously, but with the birth of ChatGPT, actually accelerated the process of creating more robust and better performance chatbot. So one example that we have in our sales and marketing is that we actually have this chatbot that provides level zero technical support. It's very much like a lot of virtual assistants that you see on the e-commercial website, or even Singtel, you have Ask Shirley or something like that, right? Yeah, so. Is it mine? No? Okay, I'll just continue. Yeah, so basically customers can actually go to use such a virtual assistant to actually ask level zero technical questions about our products, and our field application engineers can actually focus on more critical customer support services, right? And in terms of manufacturing, we do not have it yet, but what I would see in future is that we possibly will have the possible opportunity to have a virtual maintenance assistant. So whereas we can have a virtual assistant whereby our technicians no longer need to refer to manual documentation, machine manual, troubleshooting guide. They can just ask what is and how to question to really to solve their complex equipment problem in a shorter period of time. Yeah. So these are different opportunities I would see with ChatGPT.
Very interesting. Chunyap, you wanted to add?
I mean, I agree with Pamela, but we also need to mind the pitfall of falling too reliant on AI in this case. Talk about a situation where, AI is here, but it may not be working 24 hours, 24/7 all the time. So when the situation happens, are we at that point of time still having the correct skills to deal with that current situation in this case? I mean, it does help, really, but we need to prepare for this situation.
But maybe just a comment on that, and I think, I mean, throughout the evolution, we have seen that we face with change as a society. So we have today other capabilities as years before. So I think this is also again a new phase where we learn, building up on the AI and using our own new capabilities. And for me, it's really important, the topic of open AI. We use that already in terms of, reducing time for coding for our engineers, but also making sure, for example, we have a cooperation with Microsoft, for example, where we use OpenAI in our own product lifecycle management, integrating that also with Teams, because we saw that 70% of issues which we have in industrial contexts are actually not logged, because people just don't have the time to document it, and this is now basically doing it automatically.
Very true. Anything to add? Okay. So second question. I know that when we look around the room, there are some companies that are at different stages of maturity when it comes to AI adoption. Some have invested very, very heavily and are moving forward very aggressively. Some are more towards the beginning of their journey. And so when you think about the journeys of your companies and of the industry in general, what are some of the key challenges that you see companies facing as they're starting out? What lessons do you learn? What kind of advice would you have for others that may not be as mature as your businesses?
Yeah. So I think one of the big challenge that we face is the inertia to adopt AI and machine learning in our industry. Just take a very simple, I think on my way here, if I take a cab, I have a chat with the cab driver, and I asked him, how long do you need to get a Grab license? So it surprised me, only 20 minutes. And then back in the days when my dad used to drive, he said it take him like 2 months to get a driver license. So that's how much AI and machine learning can improve our productivity. So in the early stages of adopting, say, things like virtual reality or augmented reality, we use a lot of HoloLens, virtual glasses in our daily work. But I recall in the earlier days, in the early adoption, it's very difficult to get the technicians and engineers to use it. They are so used to doing, the instructor will teach them on the real tool itself, how to do the proper maintenance and things like that. So it's an instructor-led and then very small group. And also sometimes we run out of machine time, physical machine time for them to do the training. But now if you embrace the VR glasses, the HoloLens, you can do it even without the machine physically. And the good thing is the instructor, now that with all the programming and all the coding we have done on the glasses, he can actually detect if 1 or 2 engineers or technicians is not doing the procedure correctly, because it will flag out on his screen, and he can give them real-time guidance on, oh, you did not perform this step correctly. I think that would not happen in the past if you have like 1 to 10, but now we can do like maybe even 1 to 20 people getting trained and all this in a very efficient manner. Yeah.
Very, very interesting. Did you have something to add?
Yeah, I mean, I agree with Kim Siong. It's really more on the mindset, and also most likely the fear of, as I mentioned in my presentation, losing their current jobs. That will be one main hurdle to overcome in this case. I mean, at the executives level, we are in touch with the current industry trends, etc. What can do for us is fine, but when we go down to the lower levels, this is where big efforts need to be put in this. And if we look at that in terms of manufacturing, they are actually the most important people, because they are the ones every day in the shop floor with the machines all the time in this case. Yeah.
Great, thanks. Next question. So, Katharina, you mentioned earlier some of the concerns around cybersecurity, around data privacy. What other kinds of issues or worries or concerns should we have in the industry? Do people in the industry have? What are some areas that you personally are concerned about as you think about AI adoption, ML adoption? Pamela, you wanted to answer?
Okay, so maybe I come from the perspective of implementing AI solution. What are the risks that we observe? So I think first of all, manufacturing has been existing for more than 10, 20 years, right? And it's inevitable that we have legacy processes that are still using very old network protocol, which are very susceptible to cybersecurity threat. So if you want to implement AI solutions whereby we need to do those transfer of data out, we definitely need to upgrade all these legacy equipments to better, more secure data transfer protocol. And then secondly, AI has cloud, you are also leveraging on cloud solutions. So basically there are 3 different types of cloud management system. Yeah, about cloud management system. So basically there is private, hybrid, and public types of cloud management system, right? So depending on your level of need. So for us, confidentiality and sensitivity of data is important to us, right? So definitely Infineon adopted the private cloud solution. There's pros and cons. So if you have private cloud solution, there is a very initial high setup cost, and we also need to have a group of experts to sustain and maintain the solution. But of course, then we reduce the risk of data leakage. And coming from stakeholders, like our internal process engineers and production process line, when we employ or deploy AI solution, they are always very concerned about quality risk, right? So again, we try to overcome all this by making AI more transparent to them, even with deep learning models that maybe your course instructor has taught you that it's a black box because of the complex neural network, but we will try to make it as much explainable as a white box to them to assure them in terms of the quality concern. Yeah.
Yeah, just to chime in on Pamela's point, I think one of the key concerns also is around the because with all the supervised and unsupervised learning in AI, the machine actually can make a lot of decisions on its own. Just like in the semiconductor, we train them to recognize certain image, recognize some sensor data on the machine, and make decision on its own. So many a time we have to have a very careful consideration with the customer and also with our fellows on what are the boundary conditions. If you don't define your boundary condition, because we are doing real-time decision making and as well as adjusting some pressure, some temperature on the wafer, or on it can lead to excursion, like what Pamela mentioned on quality, right? So I think having a good conversation with the customer on what are the boundary conditions, what are the allowable tunable knobs that we can adjust is very key in this AI machine learning application.
It's something that I actually saw a few years ago. I was working with a major airline on AI ML for predictive maintenance, and one of the big issues was explainability, where the model was somewhat of a black box. And we could correlate very strongly with the results, and we could show statistically what was happening, but we couldn't explain why to the engineers logically it would happen that way and why the results would follow. And so very low adoption, very low confidence in the model, simply because of the explainability. You guys ready for another question? Yeah. Okay, great. Are there certain areas that we should consider investing in more heavily? So what do you see as the biggest winners? What do you think will be adopted more quickly? What do you see as some of the laggards? What do you see taking longer? How do you see the industry evolving in terms of AI ML adoption? So, Katharina?
Yeah, maybe on the front end side, I mean, we see already activities. I think Pamela has quite also elaborated on the back end side, but I still think, like I said also before, especially automating the back end and then also using there a lot more AI because of the testing efforts which we see there. I think this is something where I see more AI in the future. But also in general, as we have heard the concerns also before, I think the option of having the power of simulation and also testing things not on site, also in a model simulating things, I think this is also something where we see a lot more, and which also gives, like, for a very conservative industry like semiconductor, and for a reason, because if you basically don't get it done, you will really have a high impact on costs and yield. So I think this is really important, where we see new ways of adapting and using AI going forward.
Okay, very interesting. Pamela, any thoughts? No? Okay, Kim Seong?
Yeah, I think like what Chun Yap mentioned earlier in the day on lights out manufacturing, I think for those tasks, very mundane tasks that in the annual career conversation with the employee, this kind of task, very mundane, it's hard to derive job satisfaction. I think these are the tasks that we should let the AI and machine learning take over. Just like automated parts delivery in Siemens that you mentioned, I think we have huge shop floor. Some shop floor in the fab or in our assembly are few football fields. We don't expect human to keep doing the parts delivery. That's where we get the autonomous vehicle. Even in the restaurant today, you can see some autonomous waitress delivering the dish to you. So we are adopting this. And also an element of human fatigue. I think this is very important. Just like, for example, in the medical, you have radiologists looking at your MRI, your X-ray. In our sector, we also have a lot of technologists reviewing defect SEM images. And those are not easy. I think you can review 10 pictures a day, but these people are reviewing thousands of pictures a day. And that's where the fatigue set in. And when the fatigue set in, you may miss certain critical defects. And then you may miss a certain thing and excursion happen. So these are the ones that we train the machines to recognize some of the images, and then we can do the defect classification and very, very accurately and very repeatably, because these guys are no fatigue. Yeah.
What do you think will be the slowest to adopt? What do you think is the most difficult? So we talked about the easiest. What do you think will be the most difficult to adopt?
I think in terms of those real-time conversation, like if you need to speak to a psychiatrist on your problem, we have seen many areas where we kind of chat with the robot, And this real-time interactive communication is really tough to adopt AI. I would say maybe you need a couple of years so that you can, the context of the question asked sometimes can be misleading to the AI engine. But for in the semiconductor world, I think we do have a lot of very structured, very repetitive tasks that is very easy. Not so much of those real time. I think when you speak to your psychiatrist, or even when you want to speak to the bank, you don't want to speak to a chatbot. You want to speak to the real person so that they can understand what is your true concern.
Yeah, I mean, I agree with this. Even during meetings, we would like to see physical people around rather than talking to a screen. And you just don't have that human touch in this. I think this is one of the main challenges that AI really needs to overcome, the humanity factor in this case. Because we are still people with feelings, unless we can replicate that. If not, it'll be really hard for this. Yeah.
Good points. It touches on something that you said earlier, which is around the concerns that that people have and employees have around automation, around job loss, around the transformation of the industry. Do you have any thoughts around whether roles will be obsoleted, whether it will, you hear differing opinions where some people say it will create more jobs in the future, versus people saying that there will be some categories of jobs that are obsoleted. Do you have any thoughts around how it'll affect employment, skill sets, overall industry growth?
Yeah, I like to take this. It's a very interesting question. I think like when you visit a doctor today, you expect to walk out and then be functional even on the same day. So same, a lot of our customers in this room, they expect our machine to be less intrusive for preventive maintenance or corrective maintenance. So it is true. We have very much, get rid of a lot of wrench time that we are doing on the tool, because we have robots to automatically replace some of the consumable without human intervention. But I think as Applied, we also partner with a local university like the Singapore Institute of Technology in part of our Upskill 2030 program. So we have a vision by 2030, right? I think we want to retrain a lot of these wrench time workers who are mainly, doing a lot of machine PM, which is now taken over by the robotics. Right? We want to retrain them, upskill them. There are still many things they can do. So if you train them on coding, because a lot of the calibration and all the things are done by wireless wafer. So now they need to go calibrate those wireless wafer and then calibrate all the sensor, and then some coding on how do we look at the productivity of the preventive maintenance. So there are tons of things that these people can be trained on. And we are very glad that local universities are also reaching out to us to partner with us and also with the government, like the Skill Future and in Applied Material, the Upskill program to retrain some of these stuff.
Yeah, I would generally also support that. I think we will see a lot of new jobs going forward, but also we will see, obviously, jobs which are very much easy, repetitive work, which we have seen, which will probably disappear. But then you have a lot of new opportunities going forward, where new things will be created. And I mean, we are also working with the Institute of Technology here in Singapore, also having programs like term in, term out, where you, during your studies already, can practice in the industry, combining really industry knowledge with, research, and have that already incorporated very early. I think this is really important to make sure people understand very early in their career what is really important, where they need to focus on, to then be also able to perform well and also have a job in the future.
Very good. Other thoughts?
Maybe I can just add on a bit. So just maybe one example, like we have our product engineers job really day in, day out to analyze about yield performance of our certain product and things like that. And imagine automating this entire work process for an engineer with a bachelor degree, right? And what else can they do? I mean, if they have been spending like 20 years, 30 years doing this. So actually, I mean, with all the advancement and improvement about special projects like South manufacturing, actually we need their help with their domain knowledge, their experience to work on all these special projects to drive further improvement and further breakthrough for our organization, right? So taking away all these day-to-day firefighting job using AI and asking them to focus on more value-adding tasks, I think is more meaningful as well, right?
I mean, also just an afterthought on the market demand as well. Yeah, we see that right now, in the past, the cars are getting more and more advanced. We need more chips for the cars. Manufacturing increases because of this. Maybe what type of wave can AI do? What type of things are coming up to support this? Is the manufacturing going to change, or there's new needs for new things coming up? And yeah, and in the end, the demand for chips go up again in this case. So it's something to consider as well. Yeah.
Excellent. So another question for you as you think about this, and I think, Pamela, you mentioned in your presentation driving the adoption and the knowledge of AI and data science across the enterprise, because it's not just the engineers that need to understand this in order to run the business. What I tend to think about is that when I was an engineer, everybody needed to have their own continuous improvement projects, and the continuous improvement projects obviously leverage the kind of knowledge that you have, that the more AI, the more data science that you have as a foundation of understanding through the technicians and the operators and the engineers that are on the shop floor, the different quality of improvement projects you will get nominated and get performed. So what do you think, what do you find in your business or in the industry helps in disseminating that, that culture of data science and AI across the enterprise?
I think it's a combination. So on the one hand side, for example, we in Siemens, we have like a digital learning platform where we have a variety of different courses to different topics, also AI. I think this is one hand where you also be, you need yourself motivate, also learning constantly, really with a growth mindset, further developing yourself. But on the other side, I think also as we have heard before, the human touch. How can we really make sure we get people in for these new topics? Gathering, using also, personal gatherings to really push out this topic and join forces to bring things forward. So I think it's a combination of, digital abilities and then also physical abilities where you bring people together. So really connecting the real and the digital world to also bring AI forward.
Okay. Other thoughts?
Yeah, I think I'd like to add a comment on, just now I mentioned about the adoption of like HoloLens and virtual class in our training. Actually, globally, we have customers across the globe, right? In the Asia region, in the America region, Korea, Japan, China, everywhere. So I think if we have a global adoption of Google Glasses or virtual reality, HoloLens and things like that, we can also assist the customer in getting their tools. If, for example, the expert is in certain part of the world, in America, and the issue is in Asia, and he couldn't get the person, on time or fly him across the globe so fast to attend to the customer. We can don the virtual reality glasses, and then through there we can do a step-by-step guidance on how do we resolve the two issue. So I think these are very, very tangible global benefits of if we have a global adoption throughout the organization. I think it's going to really improve the speed to solution and also scale up the productivity.
Good, good. A related question around that. One thing that occurs to me is one of the things that has enabled the scaling and the growth of the semiconductor industry has been the adoption of standards through standards bodies. And you mentioned, you mentioned specific products and saying, could we use this specific product? But at this point in AI and ML, we haven't yet moved towards standards for a lot of these shop floor solutions. That a lot of companies are experimenting to try to develop it. Are you seeing standards evolving? Is the lack of standards right now hindering or holding back the industry? What do you think needs to happen in order to make some of these solutions more standard so that they're implementable at scale so that companies can really see the benefits? What are your thoughts?
Okay, maybe I start first. I think best practice, BPI is pretty popular in semiconductor industry and across companies, right? And also work method harmonization. I think the very important thing that we see when we are trying to scale AI solution across similar process, similar equipment platform, the challenge that we have is not the data standardization, that one we can handle, but it's really the work method, because you go to different countries, the way that they handle problems are different. And if you want to implement an AI solution, you want to change the way that they work, again, starts with change and how ready are different production sites ready for this change. And then it brings across the other perspective that we need to have the right organization set up to support this. And in this sense, that means we need to have focused team whereby when we want to scale fast, we need to have these people in the ground to help us do this. Yeah, so in Infineon, we actually set up, we don't have a centralized function. I mean, we have a centralized function for AI, but we also put in our army in little production site to look at what are the AI opportunity that they can do within their site, but to avoid the silo mentality that each site has their own AI solution, we also have this centralized team over here that we look at what all the sites are doing, which sites are applicable to take this solution to scale to them, and what are the gaps to close to make them scalable, right? So we prepare for all this before we even thought about, hey, I want to pull your project in to scale to this site. Yeah, so these are some of the things that we do to scale faster. It's definitely a topic, yeah.
Other thoughts?
Yeah, I think standardization is very important, because many a time when we deal with various customers, the platform that they use, even the type of Google Glass or the virtual reality glasses that they use is different. And then sometimes the network that they use, some countries are still 4G, some are 5G. Obviously, if you use a 4G network to do those real-time virtual augmented reality call, you're going to have a lot of lag. So whatever the one person maybe say, I want to close this valve or do this, but when the lag comes, you could be opening or closing the wrong stuff. So I think some standardization on 5G, or certain form of Wi-Fi or network communication is important to establish globally. And I think Applied, as well as many suppliers here, are also fueling the chips to support all this communication. That's why the ecosystem is really important. Yeah.
Excellent. So I think we have time for one more question. If anyone has questions in the audience, please feel free to submit them. Last question that we've prepared, and especially with your role at Applied Materials, and thinking about this, very little of what we can accomplish in the semiconductor industry do we control within our own four walls. We always have to collaborate with suppliers, with partners, with customers, with the extended supply chain. Given that necessary for collaboration, what kinds of things can companies do with AI and ML to bring along their supply chain partners or their suppliers or other partners to ensure that they get the benefits of the extended network, the extended ecosystem? So go ahead.
Okay. And I think there are lots of fields where you can look at, but like, for example, the software I've presented earlier, Seagreen, is basically one tool where you can connect across the ecosystem on sustainability, sharing basically Scope 3 emission, also using AI, looking into the respective data. So I think these are, very concrete examples where we can connect. Also the topic of going forward, industrial metaverse, where it's a lot easier to connect digitally, what you just said in terms of virtual reality. If this is really coming through going forward, and we really expect that coming through, but we also see that it takes longer than we thought, because we know virtual reality for quite some time, but it's still not that we are sitting here with our virtual reality classes. So I think this is still some way to go there, but if we look really there in this direction, we see going forward it makes easier to collaborate also across the ecosystem, because digitally, wherever you are, you can easily connect.
Kim Seong?
Yeah, I think just like the EV, right, we are also struggling on what kind of battery platform and all this to have a common, so that when you talk EV across internationally, you can charge the vehicle in a very universal method. Even in our phone charging, USB-C is the new norm to charge. So I would say that I think as an industry ecosystem, all the major players, we need to come together and brainstorm on what are the platform, the most efficient way, the best known knowledge or method that we can collaborate together from the supply chain to the tool manufacturer to the fab on how do we conquer these together and collaborate on these. Yeah.
Okay. Other thoughts? That was the last question that I had prepared. I'd like to thank all of you panelists. Anyone have any closing thoughts you'd like to add? We're very shy today. Okay, thank you very much for your time. Thank you for the audience. And look forward to speaking with all of you if you have any questions or any discussions that we have over lunch. Okay.
Thank you.
Thank you.
Thank you. Thank you.
Thank you. Big hands to our moderator and our panelists. Thank you so much for the sharing. I think a lot of ideas are bounced off right here at this panel discussion. Thank you once again, ladies and gentlemen. Shall we give big hands? Thank you, much appreciated. And of course, I guess during the lunchtime, we'll be able to grab them if you have any further questions as well. And this room will feature a presentation on digitalisation, automation, and AM, additive manufacturing. So it's a free sitting for this afternoon session. Not forgetting to remind you once again on the Slido app so that we can all have some questions. If you have any questions in mind, at any point of time, you can key into the Slido app for the presenters. All right, to kick off, we have two speakers to take us through the history of AM additive manufacturing in Singapore, followed by a look at how AM adoption enhanced the supply chain resiliency. So first up, we have Dr. Ho Chao Sing, CEO of Multinational Additive Manufacturing Innovation Cluster, adjunct professor at NUS College of Design and Engineering. He began his career in the semiconductor foundry industry with chartered semiconductor in various customer-facing technology and engineering operation leadership roles. Today, he will be speaking on state of AM globally, how AM intersects with the robotics and AI, sustainable production with AM, and finally, solutions to overcome barriers to adoption. So, ladies and gentlemen, let us give our applause to welcome Chao Sing on stage. Welcome.
All right, very good afternoon to everyone. Thanks for spending time here with me for this session. I know it's just right after lunch, so if you feel like you need to stand up and stretch, please do. I'm going to just spend the next 20 minutes to give a sense of what's happening in the additive manufacturing space, and hopefully at the end of the talk, it will give you some ideas on the relevance, how to apply for this in this semiconductor industry. And yeah. So maybe you can switch the. Okay, all right, that's good. Okay, so I wanted to start with this. I think we all know that we're not in a same state as where we were maybe decades ago, and I think. A lot of things that we are doing today is not sustainable. So we're facing this planetary scale challenges in climate change. I'll explain a little bit how this relates to what we are doing today. If you look at the kind of contribution of the GHGs, from different industries, from the energy space, a lot of effort is going into the green energy transition, but not a lot of effort in the manufacturing engineering industry. And this is where I hope that, with this talk that I give you some ideas where additive manufacturing plays in this part. I want to kind of give you this quote, and I think in a lot of ways it pertains to, for industry like the semiconductor foundry. I mean, this is like barely maybe half a century old. It has come a long way since the days when the size of a transistor was like the size of my palm. But it's true that we need to think of new ways to not just make things, grow food, and even move people and goods, right? So, and this is very important with technology. This is about applying it for the betterment of society and, of course, for the environment. And the history of humankind is that we have done this before, right? You look at the, at least a century ago, when automobiles were first invented and mass produced, this is what it looks like, right? A lot of people, basically assembling a car. You look at what is happening today in some of the state-of-the-art automotive, factories. Of course, this is we all know there's documented challenges with, full automation. But the truth is that the technology is there to improve productivity, but more importantly, to help us to sustainably produce, and of course, to develop some of these new products that we're harnessing. And this is a semiconductor industry talk, so I would say there's a huge reason why we are here today, in the sense that the invention of the transistor and the evolution of the semiconductor industry has in large part evolved and drove a lot of the innovations that we're seeing today. And additive manufacturing, in a sense, is a digital technology, has no difference. It has a lot of impact coming from the fact that we now have this access. Today we have this concept called infinite computing, which essentially is characterized by three trends that come together. One is the exponential increase in available computing power. The second is the democratized access to that power. And last but not least, the precipitous fall in the cost of that power. So you combine all these three together, what you will see today is basically this massive ubiquity in the technology in whatever we do, right? Today, all of us have 3 to 4 smartphones and computing devices. And this is not something that was the case just 20 years ago. You can now, deploy multiple parallel computing power just to solve a problem, and that reduces the costs. And that's what drives the technology evolution. And I will make a case here for all of you that additive manufacturing driven by this digital technology evolution is an exponential technology. And I'll briefly describe what that is. But first, let me just quickly introduce myself. So I'm from the National Additive Manufacturing Innovation Cluster. We started about 8 years ago. The mandate given to us 8 years ago was we needed to figure out how to translate the research that was happening in the research institutes and universities so that we can actually value capture that for the Singapore economy. And the structure of this setup that we have done is we have established translation teams in all the major additive manufacturing centers in the universities and research institutes. So we're currently 8 strong. We have 8 teams, discrete teams that are co-located with the AM Center of Excellences in the IHLs and RIs. And we are very focused on the industry-driven application type of translation work that can actually apply with additive manufacturing. And sort of give you a sense of the map, just to tell you that Singapore has invested heavily over the last decade or so. So we have a lot of these domain expertise, infrastructure, and as well as people to support any kind of industry applications that require additive manufacturing or you see a value proposition. And additive manufacturing, to a lot of you, some of you may think it's a rapid prototyping, some of you may think it's 3D printing, but the fact is that the value proposition goes way beyond that, right? So we're talking about this freedom of design because it's built up from the grounds up, molecular by molecular. You can actually design very bespoke, very complex geometries like the one I've shown on the picture. Looks very alien and very organic, but it's actually a heat sink, right? So the idea is actually to maximize surface area ratio to volume with lower material usage, and you have better efficiency in terms of the heat transmission. The second concept is this concept called digital warehouse. So as opposed to traditional spoke and hub model in the supply chain, people are not talking about how do we create this massive digital libraries of qualified part designs, where at any point in time in your business, if you need to built on demand, you can do that, as opposed to the current model of overbuilding. Third concept is the sustainability element, which is very much related to materials, the materials of use. You could actually use recycled materials. As an example, we have established a foundry in Singapore is actually a material feedstock company called Molyworks. They recently rebranded themselves to call Continuum. But the idea is actually to take scrap metal, which is everywhere, and basically process into a form where it can be applied for remanufacturing of new parts. And last but not least is this decentralization. Some of you may know it as localization or glocalization, but the concept is really about building resilience to our current global supply chain. You can do that if you combine this digital inventory concept and, of course, having these micro factories that has the additive manufacturing capability with design at the point where there's a demand. So I wasn't assuming that everyone would know what additive manufacturing is. So there's actually a whole family of technologies. For the semiconductor wafer folks, I would classify any of these film deposition techniques like PVDs or CVDs as a class of additive manufacturing. Anything that basically you're building materials layer by layer, or you are building very complex shapes and geometries, these are all considered additive manufacturing. And this is actually a standard. ASTM is a international Washington-based standards organization. They have defined what is additive manufacturing. But just bear in mind, this is not comprehensive, right? So just to give you a sense of the global market and the opportunity, today we're talking about, in terms of the value of the products and services with additive manufacturing, it's somewhere in the ballpark about 18 billion. The interesting thing about the trend, if you look at it, is in the last 11, 12 years since we've been tracking this, it has grown exponentially. And one of the points that I wanted to say is that if you look at the value of the total manufacturing output globally, and this is estimated somewhere in the ballpark of 16 trillion, we're talking about less than 0.1% penetration, right? So most products today are traditionally manufactured using techniques such as machining technologies or injection molding. From an economics perspective, for mass manufacturing, this makes a lot of sense. But for cases where you need to customize or mass customize, you need to build high mix, low volume kind of product mix, additive manufacturing becomes economically more sensible to do because you avoid overbuilding massive digital physical inventories. The other point is that the use cases, which I think some of you may be wondering, has gone way beyond rapid prototyping in terms of building hobbyist toys or whatsoever. This is now an industrial scale technology we're talking about. I don't have examples, but if you go nowadays Google or ChatGPT or BART or whatever, you'll be able to find a lot of examples of the different very industrial scale systems that's already commercially available. To give you another perspective, I think globally that's the picture. Singapore has been investing in this space for the best part of the last, I would say more than 10 years. And in the last 8 years, we've focused a lot on translation. So what has happened is that we have worked with the economic agencies, with our local industry ecosystem to build out the entire value chain that is very much necessary, right? Very much like what you see in the semiconductor industry today. You know, for the fabs to flourish, you need everybody from the equipment makers to the material suppliers to the software solution providers and so on and so forth. So we have done exactly the same thing so that we can build out the partners, right, to support the economic value capture activities. And a very compelling thing that we have, again, these are very high level. I just want to give you a sense, but a lot of details is there. So if you're really interested, you can always send me a text or email. I will be more than happy to spend an hour with you to explain. But essential thing is that when we look at the futures, what Singapore can do, and manufacturing is a very big part of that, 20% of GDP. We need to transform a lot of the traditional manufacturing industries to utilize this technology so that it can value capture, and more importantly, to value create and move into new business adjacency. A very classic example is a contract manufacturer moving to become a product OEM. And I think this is the aspiration that a lot of companies have, because it means that you have control over your IP, right? You're not at the back and mercy of the OEMs themselves. So this is something that we think this technology helps companies to be able to develop that. And in combination with the other very popular domains that you've heard on, or probably too much, artificial intelligence, robotics has been around for years. We think these three key technologies combined with design data will be the key enablers and pillars for the future of modern manufacturing. And Singapore is actually very well positioned for that because of the huge base of large industrial players. In the semiconductor space, which I was in for many years, and it's taken many, many years to build out, and I'm glad to still see, continuing investments from applied materials and so on and so forth. This is a very big part of it, right? So it's innovation that drives industry, and we have to figure out how to utilize these kind of technologies for, to support what we need to have in Singapore. Let me go through, before I give you some examples on the semiconductor applications, I thought very helpful to explain a little bit about design, because I think among all the value proposition in additive manufacturing is the real key thing about this technology is the design aspect. So you need to start at the beginning of the product life cycle, as opposed to taking a traditional design part and trying to just do it with AM, because economically that's not the most sensible thing to do. You need to be able to harness the value, which is be able to create these very lattice optimized, topology optimized kind of structures, which is physically simulated to make sure that it can be functional. So you can see from the left to right how a traditional bracket design can, using injection molding, once you go through this physical design process and simulation process, you can reach the point at the very right, which looks kind of organic and alien, but in a way, this is kind of things that we think is the value proposition. And for a lot of industries, if you think about even whether it's electronics or physical assets that's pretty much in every manufacturing industry, reducing material waste actually is a very, very key part of what we need to do, right? Because it's not just about environmental friendliness, but I think at the business level, you're thinking about how can I reduce costs and profitability. So this is something valuable. The pathway to that is not straightforward. So what we are trying to do, and this is our role as the government-funded organization, is to help companies to figure out what is the best way for you to embark on this journey. Okay, and I want to show you one example, which is very interesting because we have a lot of these software companies, and for some of you may be familiar with computer-aided design, which is visually, if you're a designer, you think about what design you want in your mind, and you go through this computer-aided process to draw out the designs. But today, harnessing, the computational power we have, and in some ways, the generative design concepts, this is actually a company now in Singapore. It's a German-based startup called Hyperganic. So what they've done is basically they are able to generate these designs using computer intelligence. So you actually design it, you tell the computer what is the thing that you want the product to do, and then the AI engine behind will actually create the actual designs for you. So this is very powerful. So you can reduce the design process within, cut it like 50% and more. Now let me just quickly switch to the context, what is relevant in Singapore. And I think this is just some of the newspaper cutouts that we sort of took from various reports. And I think the message here is very clear, right? I think for any industry, even for the semiconductor wafer fab industry, which is probably one of the most advanced manufacturing sector, you need to think continuously, how do you innovate in order to be on the forefront? And I would say, beyond the technology element, I think it's also the talent part. The talent, the people development is just as key, right? Because machines can only do as much as what you tell them, but it's really the humans that is the architect of all these. And of course, the net neutral target that pretty much every country now in the world has signed up to is very important. For Singapore, and I think some of you may be aware, we have a target to be net neutral by 2050. Beyond the green energy transition, and of course beyond the transportation strategies that we have, less cars, maybe more EVs, is also to look at the entire supply chain flow, right? Look at the carbon footprint at every step, from the sourcing of your raw materials to how you actually manufacture this, to the kind of power you use to power your factories, to the amount of water that you use. These are all things that actually makes a lot of difference. A small snippet that I maybe would share is that until I was out of the semiconductor industry, I didn't actually know, because I was an integration engineer back then, and one of the material that we were using was cobalt. And to my shock, that when I read an article that cobalt is actually mined in primarily the source is from one country in the world, and it's actually done in a very one of the most unethical ways you can imagine. So this is one of the things that as an industry, for you to continue to prosper, to grow sustainability, you need to think about all these things. So there's a lot of examples and how additive manufacturing has started to enter into the semiconductor industry, and I think it's useful to tell that. I'll give some examples in a while about how it's used for semiconductor equipment parts and things like that, just to show the value and the power of the redesign. But it's also good to show you that a lot of the companies already, and some of these names are very familiar to you, some not so familiar, has already embarked on this journey. In the electronics 3D printing space, which some of you also may be quite familiar, there's already quite a number of these companies like Automac, IoTech. A lot of these are very small companies right now, but they're trying to build this capability where you can actually do some of these 3D ICs in a much more efficient way by actually printing some of these copper pillars or interconnects, 3D interconnects. So these are different ways of compared to what we are currently doing, in the wafer processing world, and something for food for thought for some of you who are involved in this space. And of course, again, I mentioned about the wide family of technologies that we class under additive manufacturing. One of the key ones that we think is very relevant for this community is the micro 3D printing, which is this company called Nanoscribe. So they use this 2-photon polymerization, very similar to kind of for those who do lithography, you understand the concept. So they are a company that we've been tracking, and there's actually some of these infrastructure also in our local institutes. If you're interested to find out more, to see how that value adds to your business, please reach out to us. Okay, let me now switch to the part that probably a lot of you is like, okay, what are examples here? So these are not new, and a lot of you could just Google it. A lot of examples coming mostly from 3D systems because they have done a lot of work in this space. So the three parts to this, right? The legacy part, on demand, is one of the key value proposition. The other part is the redesign to improve the functionality, and I'll give some examples in a short one. And last but not least, of course, to reduce the material use in some of these redesign of parts, such as part consolidation and so on and so forth. And this is a kind of map to show you what's already has been looked into. And I'll go one by one. The first one is the fluid manifolds. So this design, you can see it's extremely, very, very interesting because it's part consolidated. The traditional part that was designed actually comes in 20 different parts, and then it's sort of welded and assembled together. Today, this single part is actually designed and printed. Okay, so you can only do this with and this is of course using a class of additive manufacturing technology. We call it powder bed fusion. It's extremely mature. It's now used in the space industries by SpaceX, by Blue Origin to actually build space rockets. So it's a very validated process, and standards has been created over the years. It's no longer the case where you print the first part to the 10th part. They're all different in quality, right? So the global community recognized the need to standardize the process to make it more manufacturable. So that progress, I'm glad to say, has happened. The other example is this, this heat sink, right? Which you can see the very intricate channels, underneath. Of course, it's peeled off, and you can see that with this kind of design, it's very difficult to create a mold, and very expensive to create this kind of mold, right? Especially if you're doing, one-off part from time to time. So the semiconductor equipment guys are actually looking at how to deploy this to not only better design the part so that the wafer fabs can, get better yields, get less of these excursion issues that I used to encounter when I was an integration engineer, but essentially used to lower the cost, right, for what they do. This is another example for VDL. It's a fixture, so sort of flexure, design. So what they have done is, created this, with a lot weight reduction, a lot more stiffness, and the functionality also improves as well. Another example is this shower head deposition, and you can see the example where, again, inside this tiny holes, the holes actually are different sizes. So they are simulated to maximize the performance, right, of these shower heads. And you can actually only do this through 3D printing, right, to have different size holes, that you can't even, see yourself. And the second last example is this gas conveyance and mixing type of device, usually used in the cleaning and etching tool. So you can use less components. Again, part consolidated. Again, you can see the intricate design that only can be produced by AM. And last but not least is this other example on cooling efficiency. So you can actually, get better thermal temperature uniformity and performance. I want to end here because I'm run out of time. So essentially, the message here is that we have built very vibrant Singapore public ecosystem. We have a lot of players in the industry as well. In fact, the speaker that follows after me, Sean Louis, is a veteran in this industry. So please feel free to reach out to any one of us if you're keen, right, to embark on this journey. And we welcome collaboration with all of you. Thank you very much.
Thank you very much, Dr. Ho, for your sharing and presentation. That's right. As Dr. Ho mentioned, our next speaker in the AM field is Sean Louis, Director of Creates 3D. Creates 3D is a renowned company specializing in advanced 3D printing solutions and services for high-performance plastic and ceramic parts. Sean's presentation, Adopting AM to Improve Supply Chain Resiliency, focus on the adoption of additive manufacturing to enhance supply chain resiliency with a specific emphasis on ceramic printing for the semiconductor industry. So, ladies and gentlemen, shall we put our hands together to welcome Sean on stage for his presentation. Hi, Sean. Looking forward.
All right. Thanks, everyone, especially SSIA, for inviting me to talk about ceramics additive manufacturing today. So, in this presentation, I will just talk about some of the semiconductor applications that we've done, some of the parts, but I don't think you will see the exciting kind of redesign kind of concepts that we have in Singapore, because I think as the industries that we have, the problem statements we have here locally will also be different than those that, that are faced in US and in Europe. So a quick, sorry. Oh. Okay. So a quick introduction about ourselves. We are a local SME. We specialize in providing 3D printing solutions to customers. So that's what we started off, and this is what is our core business, to support companies in Singapore to adopt 3D printing in their R&D, in their shop floor, even for their production. Back in 2017, we decided to kind of leverage on our know-how and our experience, and this is where we started on our journey towards ceramics 3D printing. So Create 3D Ceramics actually is one of the 3 divisions we have in Create 3D, and we started back in 2017 with the pure focus of using additive manufacturing to produce technical ceramic parts. At that time, there isn't a lot of players exploring this. Most of the service bureaus or the providers of 3D printer parts were focused mainly in polymers as well as metals. So besides the semiconductor industries, we also support many other industries like the medical industries, as well as other industries like recently in the space, satellites industry as well. So if you can see, semiconductor is just a portion. So why technical ceramics? Okay, technical ceramics is also known as advanced ceramics. Okay, within the semiconductor industries, the most common ceramics that's being used will be mainly alumina and zirconia. Okay, unlike what we've most likely used to know, like porcelain, which is also a ceramics, technical ceramics have specific properties that are more interesting. For example, like high strength, high temperature or chemical resistivity. But at the same time, because of these properties, it is also very difficult to work with ceramics. For example, imagine you're working on a tile at home. Okay, if you try to drill, it's different from drilling a metal where it's more forgiving. In ceramics, if you don't do it well, you actually crack it and basically you throw it. So that is also one of the challenges why ceramics supply chain tends to be longer. So as I think if I remember correctly, last year during the Business Connect, Mr. George from Intel did mention that the lead time for ceramics parts, is about 9 to 12 months, within the semiconductor industries. And that was one of the problem statements. And to make matter worse, these ceramic parts are actually used in more critical areas. So this is where we view that Create 3D Ceramics might have a solution to offer to the customers as well. So I think Chao Seng did talk about 3D printing a lot. So here you will see about a graph that basically compare additive manufacturing and traditional manufacturing. Okay, for simple designs, additive manufacturing cost per part will always be more expensive than traditional manufacturing. But the limitation of traditional manufacturing is that it cannot produce highly complex designs that was shown earlier as well. So whereas for this kind of design freedom, 3D printing is actually what we call free. So engineers can actually focus on the problem statement and design their parts based on the functionality and the requirements and not be constrained by traditional manufacturing processes. So that is one thing that everybody have to have, that kind of thinking when they move with 3D printing. So when do we come in? Okay, sorry. So when do we come in? Okay, so when we talk about the traditional process, we have the forming technology, which is injection molding kind of process, as well as subtractive, which is mainly CNC machining. Okay, when you compare this for low volume production, there is a limitation. So there's a very high startup cost, like toolings, like molds that a company got to invest. And that kind of investment will also restrict companies from redesigning because of the sunk cost. Whereas for additive manufacturing, our cost per part, it's for the low volume 1, 2 prototyping pieces, it's actually lower. But if you're talking about millions of parts, this is not where additive manufacturing will come in. Okay. That being said, within the semicon industries, based on our experience, we are not talking about millions of parts. The most that we're talking about is hundreds and thousands of parts. And this is also a sweet spot where additive manufacturing can come in. So in terms of the areas of support that we actually support the industries, It really depends on what the companies are within the where they are placed within the ecosystem. So locally, for example, in the foundries and OSATs, their main concerns will be, for example, the obsolescence parts, the obsolete parts. These are all their concerns that they want to address because they do want to prolong the life of their systems. Whereas on the other hand, the equipment manufacturers are looking at new ways that they can create their systems to give themselves a competitive advantage against their competitors. So this could include, looking at part designing based on functionality. It can also be looking at materials. So these are kind of the areas that different players within the ecosystems are looking at different problem statements. But fundamentally, 3D printing addresses them in different ways. So first of all, I mentioned like alumina. This is one of the most common materials that you'll come across. It's well known for the high strength, high temperature resistance, etc. And you will see that, for example, electrical insulation is one of the main usage for alumina. One of the reasons why alumina is the most widely used materials within all the family of technical ceramics is because it is the easiest to manufacture, okay, and relatively cost-effective in terms of implementation. Next, we have zirconia, or zirconium oxide. This is used mainly in cases where your parts have higher wear and tear. So it has better mechanical strength. So for example, if you look at ceramics bearings, this is a part that is commonly produced with ceramics as well. Next is aluminum nitride. This is a new material that we started to see more interest within the semiconductor industry. This is a high thermal conductive materials that there is more interest. I think it's because, firstly, the chemicals that is used in the industry is getting more and more aggressive, and there's a push towards ceramics. Second, temperature and pushing the higher temperature level also push the application of ceramics, adoption of ceramics in this area as well. So if you look at it, unlike alumina and zirconia, which is what we call oxide ceramics, aluminum nitrides are what we call non-oxide ceramics. The more common ones that you might also know is called silicon carbides. They're also part of the non-oxide ceramics, as well as silicon nitride. These are also properties that are materials that's of interest. But because of this non-oxide ceramics, it is also such properties that makes it even harder to produce than oxide ceramics. So as a result, you see less usage of this, but the properties, like I mentioned, are unique by themselves. Silicon carbide is a request that we've gotten many, many times, but sad to say, we have not cracked the code to 3D print in a repeatable manner to produce SiC. So some of the features that I'm going to touch on some of the features that where additive actually comes in. Okay, so I think Chao Seng did mention about part consolidation. Okay, this is where you actually take the design further. For example, taking 3 pieces into one, and in one of the cases that I will share is where we took 12 pieces into consolidate into one. So it might look good, but what does it actually mean on the ground? Imagine not dealing with a few different suppliers for the 12 components. That's the first thing. Assembly, bill of materials. What about when you join them together or you assemble? What about the quality checks, the QA, etc.? All these are actually costs that you don't see on the part cost. So you have to look at the entire supply chain or your process or manufacturing and see what's the entire cost of producing that part. Okay, design freedom has been talked about a lot, but I think within the semicon industry, based on my experience, design right now is probably with the local users in terms of foundries and OSATs, is less what we call less freedom right now. But in the future, if you get more experience in the terms of using 3D printing, that could then increase slowly, step by step. But whereas we've seen working with the US counterparts, the equipment manufacturers, they are more open to redesigning their components. And slowly, you will also see more 3D printer parts float to your existing hardwares, etc., in the future as well. But one thing to take note, the parts that we actually produce are similar to traditionally manufactured ceramic injection molded parts. So basically, these are molds where you inject ceramics, powders, as well as polymers, and then you go through a debinding and sintering process. In 3D printing for ceramics, we don't actually change the process of the whole manufacturing scope. We only change the forming process. So we replace the mold with 3D printing process. Subsequently, we still have to debind and sinter them. That is why the properties that we're getting is similar to the traditional manufacturing methods. But the last one that I want to highlight is fine ceramic versus machinable ceramics. A lot of audience or a lot of people in the market get confused with these two. Okay, machinable ceramics are a blend of ceramics that basically is manufactured so that you can actually do CNC cutting on them. But the properties are less well off than fine ceramics is what we do. So for example, pure alumina, 99.8%, fine, pure zirconia, etc. These have different properties, for example, withstanding 1000 degrees Celsius operating temperature, whereas machinable ceramics will not even get close to that. So it's important to differentiate these two when you look at your application and your function, the properties that you want. So what all these features, etc., what does it mean for the users, okay? If you're looking at integration of parts, okay, you will probably see a increase in production yield. In one of the cases we've come across, they are dealing with small zirconia parts with polymers, and they're actually joining them together with epoxy, etc. And the yield rate was actually 50%. Okay, so they had to deal with 3 materials, assembly costs, etc. Whereas 3D printing, we could actually 3D print the whole thing. The cost per part actually increased by almost 70%, but we saved a lot more steps at the end. And we also get almost 90+% yield rate as well. So you can actually look at that, even though cost increased 70%, my yield rate has also increased almost double. So that is some of the areas that we can look at in terms of benefits. Okay, greater functionality ties directly with designs, okay, and definitely reduce in development costs, okay. We are able to quickly prototype them, but do take note, the prototypes of ceramics that we produce are actually functional as end use as well. It's not just for form and fit, but you can actually implement them, run your chemicals, run your test, temperature, etc. So that is also where there's a slight difference in terms of how you can integrate ceramics within your R&D process. So these are some of the applications that we have done, okay? So like complex manifolds for oil, for fluid and gas flows, etc. We have also done some solid oxide fuel cells kind of parts. This I will show as a case study, okay? And do take note, the fine holes that we talk about here are down to 150 microns. It's something that we have been doing, dependent on the aspect ratios. But we have actually done some tests to get holes down to 60 microns, but they may not be perfectly round. Okay, so there are still some challenges in 3D printing, especially for very fine features. So in this case, I mentioned this is the part where the molding cost actually, the mold cost almost $500,000 US. Okay, and this is 12 parts. Part cost is about, the material cost is about $300 US per set. So the customer came to us, see what kind of solution can we offer. So first of all, we did a prototype, okay, looking at alumina, produced the 12 parts. Then we took it one step further and assume, let's say, without redesigning, we take that 12 parts and produce it in one piece, okay? So we did that simulation, we actually tried to produce them. But why you don't see a physical part? Because the part cracked during the sintering process. Why? The part was initially designed for ceramic injection molding and not designed for additive manufacturing or 3D printing. But we still went ahead, we went to do a simulation, and the break-even cost is about 1,000 cents. So we then took it further and said, what if we have the total design freedom? And this is what we did. Okay, we took 12 parts, integrated to one, we designed for additive manufacturing, we made the part lighter, smaller, more durable, okay? And at the same time, we added features like, for example, mounting brackets, heat sink, etc., to increase the performance of the parts. So you took from 12 parts into one, you simplify the assembly, you eliminate the assembly process, you simplify the testing process as well, okay? And in actual fact, the cost of the part, material cost of the part only increased by 5%. So yes, it costs more, slightly more in this case, because we actually reduced the number of materials that we use. We made it lighter, smaller. But for the company, when you add up, it's not just the 5% they're paying more, but they're actually saving significantly more in the latter processes as well. So now I talk about renewable technology. This slide actually shows some of the parts we have actually produced for specifically to semicon industries. Okay, we have created wafer support within the microwave systems, nozzles, small shower heads, covers, some manifolds, lifting pins, okay? But fundamentally, what you are used to with ceramics, we are just expanding that kind of areas and replacing traditional manufacturing with 3D printing. So this is a case of the lifting pins that we've produced. There's a couple outside that you can take a look at it. So one of the problem statement is that it's currently all your supply pins or most of the ceramics that you're getting actually is supplied overseas. There is, I think there's only one ceramic injection molding company that produces ceramics in Singapore, probably two, and they are more in the consumer electronics, automotive, rather than in the semiconductor industries. Okay, long lead time, and assuming that you want to change your design, the manufacturer will tell you, no, this is the only part that you can buy. They are not that flexible, okay? So what are the limitations to us? One of the, these are parts that we are getting from the foundries or the OSATs. So the problem that we have is, this is a physical part. Can you please reverse engineer? When we do that, there's always questions about dimension tolerances, what is the requirements. These have to be sorted out, they have to be discussed with the customers or the users and the engineers, okay? And of course, all these parts have to be qualified at the end of the day. One of the things to take note that even though we are using additive manufacturing, if you look at the cost, it's actually very competitive when we get to, let's say, 300 pieces, etc. If you look at 5 pieces, 10 pieces, our cost will be significantly higher. But if you look at your estimated annual units of 300 pieces per year, the cost is actually quite competitive and is easily, what we say, adopted by customers once they qualify. But while cost is important, I think we have to, the most important thing I think is, I want to stress, is the second point about able to improve our existing designs. Your engineers actually has a lot of ideas to improve the system or the process, but their hands are tied. The question here is, when are you comfortable to let them explore more? So of course, the first step will be to qualify the existing designs. It will become a platform for you to qualify new designs as well. So I think this is where you will make a difference by integrating 3D printing within your manufacturing process. Next, also ceramic washers, similar issues as well, but fundamentally for this, it's about getting down to the cost. And for small washers and rollers, we are using zirconia, and the cost is about $30 to $50 per piece. So again, we check with the customers. This is the, they're working within a very specific budget, cost per part, and this is the target that we have achieved as well for them. So as mentioned earlier, we also do high performance polymer parts as well. If you look outside, oops, sorry. Oh, okay, maybe I'll skip. So basically this is a cover, if you, later I will quickly try to show, but this is a cover that was customized by the users. And they do not have the material specification, they do not have the drawings. But fundamentally, this customized part was broken. It was produced in 2 pieces, and they use a bonding agent to join them together. And it's used in the ultrasonic environment with chemical exposure. Over time, the chemicals actually degrade the bonding, and the part broke off. So this is a problem statement we have. And rather than spend dollars and cents into finding out what the material is, we said, okay, let's look at the problem statement. Okay, our engineers went in, understand the problem statement, and we said, okay, we have a solution. We chose a material called Antero. It's a low outgassing materials, firstly. Second, it also a very high chemical resistance. And we produce that in a single piece. So as a result, we don't use any bonding agent as well. So in this case, the parts is stronger and more durable, while also being chemical resistant. So this is some of the solutions that we can offer to customers when they're dealing with polymer parts. So the carrier tray, similarly, you will see a sample outside where it's meant for low volume production when you're dealing with new products, okay? There are some features that 3D printing will not be able to do. For example, small holes, tight tolerances. These are things that we cannot do, but we can actually achieve them via post-machining. So we do tweak the printing parameters to achieve the certain flatness that is required by the customers as well. By playing with all this for low volume production, we can actually be more competitive, shorter lead time, and slightly lower pricing than metal fabricated carrier trays for prototype runs for 5, 10, 20 pieces runs as well. So in terms of what is our value proposition, when we show all this showcase, all these kind of applications, we don't talk about those cutting edge designs, etc. What do we actually do? So firstly, we are being local. So what does it mean having local presence? First, We can, of course, respond faster. Okay, we have the benefits of being the print on demand when you need it. But more importantly, we are closer to your R&D as well. We can go down to your site, talk to your engineers, work with your engineers, how we can leverage on 3D printing for ceramics to give you better performance of the parts. Okay, and once you go through the R&D process, it's just a matter of step to qualify them, and you can do what we call manufacturing with 3D printing. Okay, and imagine after you sell the systems for 10 years later, you want to reproduce that certain spare parts. For us, it's just to drop the file from the digital warehouse, and we just reproduce them. And the cost will be similar as per your initial forecast or your budgeted price. Because we don't have tooling setup costs, we don't need to reinvest on the new toolings or reproduce the whole setup. Okay? Secondly is, while localized solution is good, there must be more to just being able to provide locally. So what we have here, for example, actually looking at more advanced materials. So in this case, you see that we have the aluminum nitride, but we've also worked on some materials that we developed with NTU. For example, silicon carbide is something that we are doing. We have also developed materials that is called spinel, mainly used in the bulletproof or defense area, but has certain properties that might be interesting for the semiconductor applications as well. We've also done some YAG ceramics as well. So these are some of the newer materials that we're experimenting that may be of interest. Okay. In terms of design improvement, I think that is very clear. But also for the shorter term needs, I think customers or users can look at their production floor, identify certain high wear and tear parts in, let's say, polymer or metals, or even maybe your existing ceramic coated metal parts and replace them with full ceramic parts. This way you can actually increase, the cost will be higher per piece, but you actually save a lot more from your production loss by reducing the downtime that you need to replace those parts as well. So it's about looking at the whole picture rather than just a part level component and see the value of 3D printing. So this is a simple slide to show what is the process. Normally customers come to us and say they have a problem statement, these are my requirements, etc. Send us the files, and then we relook at it and we'll advise them doable or not doable, or we'll go down to the shop floor to identify, work with them. Then once we agree what is the scope, which is the most difficult, then we produce them. Then the hard work also actually comes in also for the qualification process and how we can improve the parts to pass the qualification process as well. Okay, so yeah, that's all I can share. Of course, there are more complicated designs that we work with, but I'm terribly sorry that we can't show them here. All right? Okay.
Thank you very much, Sean, Director of Creates 3D. Thank you so much for your sharing. All right, moving now towards digitalization and automation. We have more amazing speakers lined up this afternoon for you. Many manufacturers may be familiar with metrology, technology of measuring key variables of products in manufacturing processes. Too few measurements result in loss of inline control and offline traceability, whereas too many measurements requires more money, more time and space. So our next speaker will introduce virtual metrology as a solution to the sampling challenge of physical metrology. Dr. Mike Yang-Han Kim is leading expert in information theory, data science, and machine learning. He is the founder of Gauss Labs, an AI startup focusing on revolutionizing semiconductor manufacturing. He will be introducing a VM solution to address high-volume manufacturing challenges and make them a reality. So, ladies and gentlemen, let us welcome Mike to share on virtual metrology, past, present, and future. Mike, please.
Good afternoon, and thank you very much for having me. It's a great pleasure to be here. And I guess I have probably 4 minutes to be on track on the program, so I'll try to squeeze my talk a little bit. But I'm sitting on the table 19, so if you have any questions, just feel free to approach me after. So just a quick introduction of Gauss Labs. We are a Silicon Valley startup. We are a very, very young company, less than 3 years old, but we've been already making huge progress in semiconductor manufacturing. So I don't know whether Chips Ahoy, the cookie, is hot in Singapore, but in US, there is Chips Ahoy, and we call ourselves Chips by AI because we are not doing semiconductor for AI, but we are actually doing AI for semiconductor manufacturing. And our company is kind of unique in our talents. Obviously, we are very strong in AI, but also we know domain pretty well. You know, I worked with fab people, I worked with packaging people, I worked with the IT folks for semiconductor manufacturing, and I also worked with product people. And there are a lot of experts at Gauceps who has, you know, a lot of domain expertise. And also we are very strong on enterprise software architecting. So these things combined, you know, we have our solutions, and you are gonna see some of these features when I talk about our solutions. So, I mean, we know that we are in the toughest business in the world. I mean, we have a very, very hard job. You know, the complexity is going up, cost is going up, and cycle time is going up. But at the same time, we have to catch up with the Moore's law, even progress it further, and save the world and make the world a very sustainable place. That's our mission. And the only way we can actually accomplish that mission is improve our manufacturing, especially high volume manufacturing. And we know that it involves a lot of optimization from the recipe all the way down to wafer tests, so on and so forth. And if you really think about it, to optimize something, we have to be able to control. And to control, we actually have to see, because you cannot really drive your car with your eyes closed. So metrology is really the basis for high volume manufacturing optimization. And it's becoming more and more important. The trouble is, physical metrology has huge limitations. Obviously, there is a financial cost, the CapEx and OpEx, of getting the machines, the metrology tools, and maintaining them is taking quite some money. But cost is not the only problem. There is a space issue because your fab is the most precious real estate in the world, and you cannot really fill up your fab with metrology tools because the fab is for process tools. So there is a space issue, and also there is a time not just to measure stuff, but also waiting to be measured. So this is a huge cost. And we talk a lot about sustainability in the morning and in the other room. And there is an environmental cost whenever you actually get to something that is physical. So because of all this environmental, financial, and spatial and temporal cost, we actually cannot measure a lot of things. You know, in the common language, we are actually measuring known knowns. There are a lot of known unknowns, and there are unknown unknowns, and we just simply go blind on them. What Gauss Labs is trying to do is solve this metrology challenge without adding new hardware. No new sensors, no new metrology tools, but still we'd like to augment existing metrology capabilities so that we can see more, and in fact, we'd like to actually see what's happening every time, everywhere. The product or the suite of solution we are making is called Panoptes. It's named after a Greek giant with 100 eyes so that we can really see everything all the time. And we have three solutions. You know, one is called root cause analysis, you know, combining the holistic monitoring capabilities. And we have virtual metrology, which will be the main topic of today's talk. And we also look at the imaging solutions for the both electronic and optical images. So what is virtual metrology? You know, virtual metrology is predicting the post-metrology variables by using the wafer and process state. Okay, so this is a common definition from the industry veterans, from the IEEE International Roadmap on Devices and Systems. And I know that there are a lot of experts, the veterans in this room, who knows virtual metrology, you know, probably more than I do. But just to be on the same page, let me just show you a short video explaining the concept of virtual metrology. Could you turn on the audio, please?
It's a process in semiconductor manufacturing that creates thin films on a wafer in a vacuum chamber. The refractive index and thickness of the film are the key variables affecting the quality of a wafer. Yet, it is impossible to conduct metrology physically on all of the films created on all of the wafers. This is where Panoptes VM comes in. During the CVD process, a variety of sensor data are generated. For example, pressure in the vacuum chamber, temperature from the heater, distance between shower head and wafer, amount of gas injected, and power of the RF plasma. Using these sensor data, Panoptis VM predicts the refractive index and thickness of the film. The predicted variables are highly accurate and are delivered to the statistical process control system to check if the quality is within control limits or if anomalies or any alarming trends are detected. Manufacturers can also optimize process parameters and reduce process variability through advanced process control, such as adjusting the deposition time or temperature.
Yes, so that is a concept of virtual metrology. And with virtual metrology, we now have all wafer data so that you can really use this for a variety of use cases. The most dominant one can be the control systems where you can actually control the within wafer variations and wafer to wafer variations small, and we can prevent excursion. On the other end, this can actually help you use the precious metrology resources more economically so that you can reduce the sampling rate and potentially reduce the CapEx used for the metrology tools. This is not a new concept we invented. It's been around for a while. The earliest paper we could trace is a paper by TSMC folks in 2005. And they were looking at the etchers and the CVD tools for predicting the metrology variables. And they could actually achieve the amazing 98% and 99% R-square values. So what's happening? I mean, it's been more than 17, 18 years. The thing is, there has been 300 papers out there, okay, and still there has been ongoing research, as far as I checked until last year. And we talked to experts, veterans in the field. There are roughly two responses. First, yeah, we are working on it. And second is, oh, okay, we just give up. Okay. Why is this so challenging? Because the problem is very, very difficult. So there are huge challenges, technical challenges. You know, if you really look at the modern process tools, there are hundreds, if not thousands, of sensor data. So here's a huge dimension of this data, and it's very difficult to figure out which one is the real cause. Okay? And if you have too many causes, I mean, it's like Bible code. You know, you can correlate anything and everything makes sense, but in reality, it doesn't work. And also at the same time, the number of samples, the measured wafers are so few. I mean, if there are plenty of measured wafers, you probably wouldn't need virtual metrology. Okay? And there are also issues with drift and shift because of the maintenance event, layer changes, so on and so forth. You know, the chamber state changes over time, and it's hard to keep track of that. So if you really correlate FTC data with your metrology variables, maybe it seems to be working, but next week, nothing works. And it's the process engineers who are suffering from that. And also, there is the variety of cases. You know, there are a lot of different process areas, you know, different devices, recipes, you know, multiple chambers, so on and so forth. So it's really hard to build something that works across the system. And finally, you know, the usability is always an issue. You cannot really do this for some specialists, because if the specialists work on a single model for a week, but we are generating far more devices, far more recipes, so it should be done by very, very easily by process engineers. And finally, we have to actually build something that works for the fab scale, not the lab scale, but the fab scale. And to really achieve or overcome these challenges, we need three things: the accuracy, usability, and scalability. And we actually have to achieve all of them at the same time. So when GaussLab started working on these three aspects, we are actually taking very, very specific approaches. For accuracy, obviously the average accuracy is very, very important, but we also wanted to make sure that it actually is robust against the drift and shift, because this is the biggest complaint the process engineers have about for virtual metrology. And you can see that our red curve is actually tracking the green curve very, very well, because most conventional approaches were actually taking into account the FTC data, but we actually have to build some mechanism we can actually track so there was a red curve and the green curve. The red curve is catching up with green, and we really could come up with a way that we can track the process state, the chamber state, and also we can incorporate the wafer incoming state through our own virtual metrology. And this result has been published to ASMC this year. On the usability side, what is really, really important is process engineers should be able to actually stop worrying about modeling. They don't even have to think about model. So what we came up with is complete automatized feature selection mechanism and also completely automatized model update mechanism so that whenever there is a change in the system for a variety of processes, we actually don't really have to do anything. Everything is done automatically under the hood. And finally, we actually had to build a system that really works at the fab scale. So we built a plug and play approach that works very well with the existing IT infrastructure, and it can handle thousands of metrology steps, 100,000 of different models, and 100 millions of the inferences per year. So all these things together, we actually built what is called Panoptest VM, Panoptest Virtual Metrology. It's accurate enough so that the major chip makers can now use it for APC, okay? And it works universally across a variety of cases. And it's very, very easy to use, and just with single click, they can hook it up with APC system. Okay, and also, engineers, so they can actually massage this and do their own experimentation. And it can be plug and played into the existing fab infrastructure, and it's actually handling a lot of data right now. And we are looking for new partners, new chip makers, so that we can do this transformation together. So you've been wondering how it is actually being used. So there is SK hynix in Korea, okay, and they have multiple high-volume manufacturing fabs, and they started using this for their thin film processes, CVD, PVD, diffusion, so on and so forth. Okay, and what they could do is hook it up with their AP system. So VM is feeding the values to their run-by-run control, and they could actually verify that, comparing with VM or no VM, we could actually have, 22% the process variability reduction. And this is from their press release, and obviously there are more recent results, which I'll be happy to share a little bit, but because of the confidentiality, I cannot share everything. So, if you really think about the future of virtual metrology, there is certain limitations for physical metrology. They are still very, very important, and they give us precious information, but your sampling rate is limited. And now with VM, you have slightly less quality measurement with data, but you have now all wafer data. So the information you can extract from your metrology system is much, much larger. So you can actually use it for both ways. You can reduce the real sampling rate and save on CapEx, and the VM itself will be improved over and over so that you can get more and more information. So with this, I'd like to conclude my talk. Thank you very much for your attention.
Thank you so much, Mike. And I do see that the Slido do not have any questions as well. All right, so let's move on to the last topic before the break. Okay, and it will be from ChemLine. Mr. Danny Yeo is VP of Business Development and Marketing at ChemLine. Over 15 years of expertise in manufacturing IT solutions, wafer fabrication, and back-end assembly operations. So, ladies and gentlemen, without further ado, let's welcome Danny to share on advancing high-tech ecosystems, fueling process through DOE-driven recipe, auto-generation from active golden recipes. And a round of applause for Danny, please.
Hello. Good afternoon, ladies and gentlemen. So thanks for SSIA having me over here to share with you regarding the slides that we have. So over here, what I'm sharing today is basically on the how do we do the DOE. So we do have the DOE in the wafer fab manufacturing, but the challenges is more towards that in the DOE portions, there will be a lot of recipe need to be generated. But over here, before I'm starting, so let me introduce ChemLine. So ChemLine, we are a software manufacturing company with over 30 years of experience. So we do have coverage of software solutions across different areas. So today, what I'm sharing is more towards on the recipe management portions. So what do we mean by recipe management over here? So we do have the recipe managements that cover, okay, so let me go to the next slide. Okay, so what do we mean by recipe management over here? So in ChemLine, RM recipe objects, so we call it as recipe objects. So it doesn't only cover the recipe body itself. So recipe body is just one piece of the information that required by the equipment. We do also have the ECSV, which means the equipment system variables and constants. But over here in recipe management, in order for equipment to run on top of recipe system variables, we also need to know what kind of materials in order to set up at the equipment before it runs. So that's the portions where we include bill of process as part of our recipe management. So today, but I will mention what does it more in the RM. It's more towards we include the scenarios of auto recipe creations that making use of the DOE methodologies. Okay, so what do we mean by the DOE recipes over here? So in order to run an experiment, so engineer usually need to select a design or a DOE models or DOE design in order to run the experiments that required. So over here, there are a lot of DOE has been done from whichever days that started. And how does this history that keep track in the environments or keep track in the organizations? So usually we only keep the past recipe, which means that the successful recipe will be available. But how about for those that has been failed? Why we need those that has been failed? Because in the organization, we may have a situations that engineer repeatedly doing the same mistake because the experiment is not done by only a single person, it's a group of people. So when you have the combinations of the testing, it could be already done by someone else. So over here, what we're trying to emphasize is a central recipe management control. We keep all the recipe, irregardless it is success or fail. And then out from the DOE design over here, you may have a set of DOE that you need, for example, 8 to 12 run. But at the end, eventually, you may only have one run that successfully and you would like to proliferate into the production use case. But those that in fail, it need to be keep track in the organizations for knowledge sharing purpose so that the same combinations of the parameter setting you do not need to execute again to create the waste. So over here, we can see that engineers usually need to spend 30 to 50% of their time to do the recipe creations. So later I will cover more what do we mean by the recipe creations. So, and also the development of the recipe, to cover the development of the recipe, it required long cycle time to do the creations. And furthermore, with today, I believe we have a lot of advanced equipment. The recipe itself is no longer a piece of content to run the equipment. It could be a combination set of recipe required to run the equipment. So that's where later I will share an example. So eventually, it's also engineer is struggling to find what are the existing recipe that successful, and if I want to do a new experiment, is this experiment has been executed before? Is this parameter, the input parameter that I would like to set, is it failed before? In which project? What are the combinations? Combinations over here, it could be material change, it could be equipment change, it could be part change that causing you to change the input parameter. So this is the example. So in the DOE designs over here, we choose to use the orthogonal matrix in order to create the DOE design. But of course, there are more DOD designs that are available. So with our products that available in Cornerstone. But today, I will share in the example of using orthogonal metrics. So over here, when we want to do a DOE design, so usually we started off with what is the parameter, what is the critical parameter factor that impact or you would like to try. So in this example, we have a number of, I choose an array of 3 parameters with a design of either level 2 or level 3. So then at the end, it will be create a so-called proposed run. I need, for example, 8 run to verify my experiment. So over here, before we even talk about execute the run, so you will need to use the data analytical tools to confirm mathematically, does it work for me to execute the experiment now, or I need to adjust the parameter before I done the recipe update. So this is a full orthogonal matrix. I believe some of you may already familiar. So there are a lot of combinations runs that possible. So in recipe management, what we need to do over here is we need to define what are the DOE experiments that are available. So we need to identify where do we start. The starting point is usually your existing active recipe that is currently working. And in this so-called golden recipe, so I pick up a typical example from PVCVD. So you may have a CVD process, you may have a wafer flow recipe, and this wafer flow recipe, in fact, is connect to a process recipe, and it could be also connect to some other sub-recipes that required. So back to, this is something that the example that has been shared by Mike earlier on the CVD. So in order to adjust the parameter, we may have, for example, in the process recipe, I would like to adjust the pressure and temperature. But for the sub-recipe, I have another parameter, which is calling the process flow rate or type, or the time. And over here means we have 4 possible factors for the experiments. And in the DOE design for this example today I'm sharing, it's more towards that we may need to use level 2 as my DOE design, and I'm choosing 8 run to run the recipe. Conventional way without a recipe management system in ChemLine, so you will need time to reserve the equipment tool time to get the recipe. So the engineer usually need to copy down the recipe and doing some edit, change, rename, then followed by process recipe. I would like to change the process recipe, modify the pressure, temperature, process, and then I continue to modify the entire set of recipe. Then only I get 1 run of experiment recipe available. And if I need to do 8 run, it means the engineer need to do this repeatedly 8 times, and these are consuming your tool time from the production floor. If you do not have a dedicated so-called R&D or NPI equipments, then you will need this tool time availability to do this experiment. So what we do now over here is the entire sets of recipe has been stored centrally in our recipe management system, and these are approved copy that already running in production flow. So what we need to do is select a recipe that now you would like to do for your DOE, trigger the DOE setup. It means that out from this recipe, there could be thousands of parameters. So when we talk about DOE setup means, what do I want to do now? For example, maybe material change. I would like to achieve certain target. So my DOE template has been set into a specific goal. I'm qualifying a material, I'm improving an equipment. So this template does is I would also set a boundary. What can be changed in the factor? What is the parameter range that I should control? Okay, then within this example, then we can choose what are the so-called selected DOE factor. So in this example, so we mentioned that we would choose the golden recipe of P1 with the sub-recipe of P1. And then there are the orthogonal metrics will need us to put in what is the range of parameter that you need to set. So over here is more towards on the min-max available. So the system then will preview with these variables that you have put in. It generates a comprehensive table for you to know what is the system going to generate this 8 set of recipe available. And then it will already kind of create this 8 combination set of recipe available and submit for approval. So there are still an approval process for the process owner or even for the module owner to verify if this recipe, is it valid for me to run my experiment run? Okay, and at the end, so the recipe is not in the equipment, it's centrally available in the central system. So when you want to run experiment 1, so from the MES point of view, I can set this experiment order, I need 8 run. There are individual experiment ID available. I just need to set experiment ID A. Then it will download the combination 1 to the equipment to run the verifications and follow by that. And over here, the engineer just need to set 1 time compared to the earlier that it need the 2 time. But over here now, it is all done in the system itself without any time consumption or reserve the 2 time for the equipments. So what does it mean over here in general? So what we are trying to achieve is we would like to have more equipment uptime in this particular process. So we want to have more automated validations on the recipe content. So over here, I did not share more in details. So in recipe management, in ChemLine point of view, the key value is more towards how do we create the recipe transparency. So all your recipe now most likely is in your equipments. If you want to view it, you may need to go to the floor and view from the tool perspective. And in our experience, we are able to, I would say for wafer fab, so we are able to translate all this recipe content from the tool to a computer system, up to 80 types of tools that we are already supporting at the moment. And this means that you can able to see every parameter of the recipe in the office. So that means we create recipe transparency from the system itself. So with this transparency, we can do, because it's already digitized in the system, you can do a lot of validations, control. So when I do my recipe setup, I change the value. Is it with the range that allowed by the process engineer, or this is already violate the control? So there are a lot of control and validations can be set over here, including, for example, naming conventions, on-off, cross-parameter checking. So these are some things that can be done if this has been digitized. So the third point over here is, again, to emphasize all the DOE recipes that has been created is now keep track in the system. So you are able to know out from this 8 run, which is the one that's successful. Those that it's failed in the experiments, there are remarks to keep tracks that this experiment, which let's say material X that in use cannot support temperature, whatever a value. So these are the things that you could already know. This kind of experiment combinations, this parameter setting has tried before and it is failed. And if you want to do this again, with the information available, you can contact also previous executor on this recipe. So why does it fail? Is there any things that you can improve? So it creates a collaboration platform for the engineer across the organizations. So, and what does it less over here? It means that, as I shared just now, if we do this manually, that means you have to spend the time 8 times compared to the system-generated recipe. So this is the one that we simplify the recipe generations process so that it is automatically generate for the consumptions. Okay. So last, over here, this is where I mentioned when we talk about the 83 or 84 recipes types that cover. So mainly this recipe, it could be ASCII file, it could be an XML file, it could be a binary. So with the equipment documents that supported, so we are able to create the transparency of the system so that you can view it remotely in the office. That's all I have. Thank you.
Thank you very much, Danny, for our presentation. All right, so if you have any questions for our speakers, I'm sure you can feel free to catch them right there, which is, we're going to have our tea break right now. I shall not hold you up. Let's all go for our tea break and be back at 2:45 sharp for the next segment. Thank you. See you at 2:45 p.m. Thank you. We have 3 more presentations to cover this afternoon, starting with accelerating high-tech innovation by our speakers from CAT IT and NCs. So to present, we have Mr. Desmond Tan, Regional Technical Manager from NCs, and Mr. Ang Jin Yang, Strategic Account Manager at CAT IT Consultants. So right now, let us invite Mr. Desmond Tan up on stage. Looking forward to our presentation.
Hi. Hi. Hope you guys have a fresh up with after the tea breaks, right? Let me just introduce myself. Right, I'm from NCS. I'm the regional technical manager. Right, basically I take care of ASEAN and part of Asia. Okay. So this is the first time that NCS actually take part of this event from our channels, from our channel partners, CAT IT. Right, I'm really feel pleasure and excited to join this event in my first time. Okay, so what we're going to present today is the innovation through high tech. All right, by digitalization technology. Okay, so without delay, right, let me just show you what we really do. Right, you see the animations that I'm showing here now is from IC level all the way to package, all right, in terms of electromagnetic simulations. Running through the simulation, you get all your signal integrity, your power integrity, and you get all this electromagnetic E field or current field that can be shown in your product itself. And it doesn't stop there, all right? We even simulate the whole platform of your mobile phone, all right, inside a larger platform, a larger environment in the vehicle itself, okay? And from there, right, you can do what? You can do EMI, EMC simulations, right? Yeah, probably inside a big chamber that you're going to see later in the animations, right? Extracting all the E fields and all the EMI, EMC noise from the vehicle that actually interact by the mobile phone itself, right? From the IC chip, of course. Okay, so basically, NCS is almost a 50 years old software company. All right, we provide wide range of simulations too for any discipline, like from mechanical to fluid to electromagnetics, optics, right? Digital twin as a system level simulations, right? Everything. Okay, basically. So we only do software, right? No hardware at all. And we have a lot of partnership with our market player like Keysight, National Instruments, PTC, okay? So this is a wide range of products that we have, all right, basically. And I would say that we do almost everything, all right, almost everything. In the way, we actually acquire a lot of technology from the market and the industry itself to leverage that type of technology into our platform. So what we're going to say today is basically on manufacturing of this. There's three pillars that I'm going to introduce. All right, basically, is the high tech on semiconductor in integrated connectivity and semiconductor and process itself. All right, the first thing is the bespoke silicons. Right, basically we know that high tech includes semiconductors, which is from what we see now is very niche and high tech industry. Okay. And it includes all these places like TSMC, Samsung. They're using our solutions, right, to do their 3 nanometers subcon semiconductors. And also they use our tools to basically do the power integrity, signal integrity, string down their silicons level, and also power saving as well. Right. So these are some of the so-called high-tech testimonial from our customers. People like MediaTek, all right, and NVIDIA, all right, H3C, and this, of course, there are many of them, right, basically, but we are just extract 4 of them. And if you're interested, right, we can actually give you more information about all this testimonial that be given by some of the high management of our customers. So these are the solutions that we provide from IC level, right, basically, from power integrity, power save up, PCIR, right, all the way to the signing off of the IC itself. Right, this is also a proven technology that we have provided to our customers, right, in terms of semiconductors. So I think you know, with the restricted time that I have, basically, if you're interested, right, you can actually visit our booth from KIT booth that we can actually explain more details end of the day if you are interested. Then the second one is interconnect, you know, intelligent connectivity. What does it mean is, you know, about 5G, about 6G, right? We have solutions for that in terms of hardware simulations and device simulations, right? Basically, what it does is you actually connect all these so-called antennas, sensors, IoT together to do a platform, overall platform simulations, okay? And these are also some of the testimonials that from our customers commenting that what type of solutions they are using to solve their problems, right? People like Nokia, we have also customers from Motorola, from Qualcomm, right, basically, and also from space applications in the US itself, right? They're working on some mission engineering, right, based on using our tools called SDK. Then with this, right, you know, people are using it because they can actually, there's 5 times better performance, right, 80 times of reductions, and 60% of the time cycles, right, design cycles to the market itself, right? This is the benefits that they actually use the tools, right, to solve their problems and ensure that their products should be in the market faster than their cycle time, design time. So these are some of the solutions that we have for this connectivity, intelligent connectivity. So, you know, we have various types tools that actually address in terms of these solutions itself. Then these are the proven solutions that we have with the customers. All right, some of these are actually the white papers that we provide to the customers, and they are using, you know, they have customized solution from us that run in their own design cycles. Then on the semiconductor point of view, right, we have other different solutions, tools that can actually address it, right, basically, all right. From Seagates, right, they actually, you know, use our tools to extract out more data analysis, right, from their product itself, all right. Of course, save time, right, save production cycle time, and their prototype, they reduce their prototyping as well, right, using our simulation tools, right, working on DOE, trying to extract, optimize their own products, you know, using our NC solution. So basically, this is one of the process that we actually introduced, right, to actually tell the process people that these are some of the requirements that we have, right, in terms of semiconductors. So if you can see the process, right, from front end to back end, all right, in terms of ingot processing from silicon level, all right, to slicing, to process, all right, controlling the contamination levels, etc., all right, through the IC process itself, all right, metallization, optimization, oxidization, etching, all the way to packaging. You need to package the IC itself, right, the die, okay, and at the same time, wire bonding, or if it's a FPGA flip chip dump, so dump till the PCB level, and from there we can also do reliability on PCB levels. Okay. So basically, the whole chain here we can use simulation to do it, right? Basically. Then these are the solutions for us on the semiconductor point of view, right? Basically, we can, as I say, we can do all this level, signing off the chip, by using our semiconductor solutions to do the IR, to do the power integrity, So what is the main thing that you design chip is basically you want to reduce the power of the consumption of the chip itself, all right? Less power means longer battery life, all right? And also minimizing the estate of this die, because things are getting smaller and smaller, all right? Things are not going to get bigger and bigger. It's getting smaller and smaller. And basically, when things are getting smaller, a lot of things you need to take care is the power itself, right? The reliability of the die also, the functionality of the device that need to be worked, when it's inside the package or inside the PCB. And nevertheless, that we must also ensure that more features are being implemented into this small little structure of silicon. Excuse me. So this is some of the proven technologies that we have from our customer itself. All right. So all this, it can be downloaded in our website, or you can actually find more details, by approaching me. So I'd like to summarize this, basically. So due to the rapid growth in high-tech and semiconductor industry, we are pushing limits of the product innovation and design cycle completion, right? Which means that we are pushing more feature into one single product, and we want to reduce the design cycle. Because we want to push the customer want to push the product faster into the market, right? So that they can actually champion it. Otherwise, they'll be behind time, and they'll lose their competitiveness in the selling their products. So by all this, right, traditional way of designing has to be reviewed, all right? Basically because of the increasing of the more complexity, and also the variation of products. There are more and more features in a single product, right? So this, in terms of designing all this, we have to, traditional way no longer can works, right, into this. Then visualization and simulations, right, lead digital transformation to become very important, okay? Because this important in a way that you connect the stages of decision-making, engineering, operation, covering the whole cycle of the product system. Excuse me. So by leveraging the advanced computation models, right, that you provided in your simulation environment, okay, your virtual environment, simulation digitalization, right, basically enable company to simulate, optimize their products, process systems before physical prototyping are created, which is very important because you do all this modeling, right? Basically, you do modeling simulations, thousands of time, iterations, right? You are actually trying to build up the confidence level of the product itself, right? Then during this cycle, you know how to go back to solve your individual problems inside your design itself also. Okay, so basically, for this case, you're able to optimize your products, right, process and system before physical prototyping are created. Right? I'm not saying that we will not, by using simulation, we will not require prototyping. No, we still require prototyping, but the number of prototyping can be minimized, maybe from 20 to 5, all right, basically. So you can imagine how much cost you have been reduced from that stage. And also with the 10 prototyping without proper simulations, right, you might not be able to achieve what you want as well. So you might need to do your the design recycle again to create more prototyping, all right? So of course, simulation can, in this way, it can in conjunction with the real-world measurements environment, all right? And this will actually make your simulation more accurate in the accuracy and also reliability of the simulation itself. So in summary, right, simulation digitalization, right, accelerate high-tech innovation, right, by reducing costs. That's very important, all right, because the profit margin is getting lower. So we want to reduce costs, improve product performance. You want to have a great products in the market. So everybody will go for your products, right? Like Apple, like Samsung, right, etc. And you want to also mitigate risks, right? You don't want to have risks on your design cycle. You want to be able to solve your problem when you encounter during your design cycle. And even when you fail at the last stage, right, you can actually look back into your design cycle of your simulation modeling and spot or track the issue that you need to solve, right? And of course, there's a lot of advantage like iterative design improvements, promoting collaborations, support sustainability developments. That's very important, which means that you have a flow of cycle that is sustainable, right, for your next product developments. Okay, by enhancing this approach, right, basically customers can enhance their competitiveness. That is very critical for a company to actually sustain, right? And also to bring the products and solution to the market in a faster timing, right? That is also one of the major requirements that the customer wants. Okay, so with this, I actually end my part one of my presentation. I have my colleague from CAT IT, right? Jin Yang is going to present the second half of his presentation. Thank you. So if you have any questions, right, you can approach me, right? We'll see how we can help you. Okay, thank you very much.
Right, yeah, very good afternoon, guys. I see a few sleepy faces here and there. No worries, bear with me, I only have 4 slides, and we'll inch closer to our beer in the evening, all right? Okay, so very good afternoon, guys. My name is Jin Yang here. I'm from CAT IT. So who we are basically a system integrator for all you guys over here, semicon industry guys. Right, so as you can see over there, all right, so most of you here are from semicon. You'll either be from the front end or the back end, all right? Front end, you may be wafer producers or you may be a wafer, processors, all right? And then the back end, you may be guys doing encapsulation, testing, assembly, and such. Right, so nowadays people are all talking about digitalization. Right, so how can this be done? Right, that's a very simple question. So it's a merger of doing both IT and OT technologies. And this is where we come in. We give you the expertise of how this can be done. Okay? Right, my next slide will be on the value stream mapping. All right, to do all this kind of thing, all you guys need what? Money. Okay? You need to propose certain solutions to your management. Your management has to agree that this has to have an ROI to it. So you can see all the value streams over here, all the way from the front end to the back end. Most of you will see certain areas where you're interested in. I probably got some problem here. I probably got some problem there. All right? What we do, SI, I come in and help you solve the problem. Okay? And this is the next page. All right, so doing I4, how do we go into doing I4? Right, this circle over here shows you various kinds of solutions that we provide to our end clients. It may be things like maybe RC analysis, or I need to reduce downtime. How do I reduce micro stops and such? Okay, so all we're aiming to do, we are not really inventing the wheel. We're going digital. Usually you have Monday morning production meetings, all you guys gather in one room and then you quarrel, hey, I'm short of this, and the guys, it's not my problem. All right, we'll reduce that kind of meetings. With all the dashboards you have, no longer do you quarrel, just look at the dashboard. The dashboard will say who is the one who owes who money, or who owes who stuff. Okay, it's very simple. Okay, and this is the last slide. All right, nowadays people not only do I 4.0, people go to SCM 4.0. So what is SCM 4.0? It basically means delivering your resources to your production guys on time so that your production guys can produce finished goods on time to our end clients. Okay, this is basically the end to the end. All right, so we provide such case as well. How do I do certain demand forecasting? All right, I don't want to overproduce. I want to produce to the maximum of my capacity. Maximum capacity means I don't waste money. I get maximum yield. I get maximum money. Okay, so I would just like to end here. It's a very short one. I'd like to leave you guys one of my favorite quote. All right, problems does not get solved by themselves. It solves better in a group. All right, let me help you solve your problem. Okay, any of you are interested, please find us at our booth all the way at the end, the right-hand side, over our side. All right, thank you very much.
Thank you very much, Mr. Ang. A very swift presentation. That's right, Strategic Account Manager at CAT IT Consultants. Do find him at the booth if you have any questions or if you'd like him to solve your problem. He have the solution for you. All right. Next up, we have Mr. Tang Shouwei of Optimization Analytics Technology, a Groby Alliance partner, to share on the power of optimization, driving efficiency and innovation in semiconductor companies. So without further ado, I'll hand over the stage to Shouwei.
Thank you. Good afternoon, ladies and gentlemen. Just now we hear the previous session, we talked about visualization and simulation, right? So I'm going to talk about another technology which is called optimization. Okay. So this content is co-prepared by OET with our company as well as Groby. So we are specializing in optimization, which is we help our customers to build decision intelligence systems via optimization technology. I'm going to use the next 20 minutes to introduce you briefly about what is optimization technology and use a Intel use case to show you by adopting this kind of solution and technology how much efficiency we can achieve. Okay. So optimization technology. Basically, actually, we are using this technology, this technique can translate the real-world challenges, real-world problems into a mathematical model. The challenges can be like the production scheduling problem or production planning problem. So you have so many orders to schedule, to produce, but when and where to produce which order, this can be a very challenging problem. But we can, using this optimization technique, model this real-world problem as a mathematical model. And by using Groby solver, we can quickly get this optimal solution of the model, which translates into your most efficient plan. So basically, when we use this technique, we will use a lot of mathematical jargons, like we need to define the variables, we need to define the constraints, based on your rules and KPIs. And then after that, we will have the mathematical solver to get the optimal point, which is the lowest point or the highest point. That will be the most efficient plan. So normally, we do it through a system. So a mathematical model cannot solve your problem. We need to translate this into a system or software that can automatically read your input data. Input data could be your forecasted plan, your capacity of different factories and the locations of different factories. And based on this, we will have our software that can read the data. Based on the logic, we can generate the mathematical model, and then we will call the mathematical solver to solve the problem. And then after we get the solution, then we will display the optimal schedule with the graphical user interface for you to view, verify, sometimes do some manual adjustment. And then lastly, if you are happy with it, you can just execute it. Okay, so what kind of problem this technique can solve? As I said just now, for semiconductor, it can be your production planning. You have so many orders in the next 6 months, which factory to produce which order at what time, this kind of decisions. As well as your capacity. It's like your forecasted demand in the next 10 years is like this. Should you build more factory, and where? Or should you close some factories? So this kind of solutions, we can use optimization technology to help us to make the decision faster and more accurately. Okay. And of course, there are a lot of other problems we can be addressed by this technology in the supply chain, like how to set up your network, or how to schedule your transport of your orders, etc. So this is a very brief introduction about what is optimization technology. Next one, I will use a use case to demonstrate, to show you what kind of a real problem we can solve and what are the benefits we can achieve. Okay, this use case is actually from Intel. Intel actually won this Franz Edelman Prize of Informs. Informs actually is the world leading institute for OR and management science people. And in this institute, every year there will be a conference. And in this conference, there will be an award granted to the most successful industry project. So which is called the Franz Edelman Prize. It's like the Oscar prize in the film industry. So in 2020, Intel, this project actually won this prize. Okay, a bit introduction about this project of Intel. So this project actually is done two parts. First of all is the design optimization, and secondly is the supply chain optimization. Okay, product design optimization. Generally speaking, when Intel designed their product, they actually, before do that, they have a forecasted market demand. So their goal is actually to produce what the market needs. If what they produce and what the market needs, if there is a gap, that means, first of all, it's a lost revenue. And secondly, it's an inventory. Then how to design the best product so that they can achieve the best revenue? So basically, depends on the market research. Actually, different customers need different configurations. Some customers need more cost. Some customers need higher frequency. And some customers may be more concerned about the power consumption. But there's so many features and so many SKUs they can design. But how many SKU they should have and what's the configuration of each configuration, then it's a typical optimization problem. Because first of all, they don't want to have too many configurations, because with too many configurations means the design cost will be very high. But they also don't avoid to have too few configurations, because if you have with too few configurations, each configuration will be very expensive to produce. So it's a balance about the number of configurations and the cost to produce the configurations. Normally what they do is, first of all, they have all the features. They have one base feature to cover all the demand, but they cannot produce this one because this one will be very expensive. And some of the customers will not be able to pay this kind of price. And then based on this, they divide this base configuration into several sub-configurations and continue to branch out to sub-configurations. Normally, they can branch out to like hundreds of different configurations. And then they need to choose among all those hundreds of configurations what other configurations they should choose and should produce. First of all, they need to control the total price, which is a combination of the design cost and manufacturing cost. Secondly, they want to have this configuration to cover as much demand as possible. So it's a typical combinatorial problem. We can use a mathematical solver to help them to solve. And of course, with a solution, we can get the optimal configurations, but we can also to do scenario comparisons. For example, for this example, if they change one of the configuration, combine two configuration to a one configuration, what's the impact? They can say, okay, by doing a little bit of adjustment, they can achieve like $750 million of saving. So this is a typical design problem. They're actually adopting this kind of technology to help them to do better design. Secondly, after you finish your design, then you, broadcast, this is going to be my next generation of the CPUs, etc. And then they will receive a lot of orders from their customer. Then how to produce them, how to deliver them. Because for Intel, they have like hundreds of factories, and they have a lot of orders, thousands of orders to produce, and and at least 6 stages of process they need to go through each order. And with all these combinations, it's very difficult if you want to plan the production manually. For example, of this order, need 5,000 CPUs of this configuration, and where to produce this CPU, in which different factories. Because it involves the production cost, production capacity, transportation costs, etc. All these rules and KPIs are involved. If you plan to up to thousands of orders, it's not possible for human brain to actually to work it out. But this one is a typical optimization problem. Why? Because given all these orders, given all this factory and their capacity, etc., they can have millions and millions of different choices. But among those numerous choices, some of the choices are very good quality, and some of them are lower quality. So our job is actually to find the best, the most efficient plan. Okay? We can model this problem into mathematical models, and by finding the optimal solution of this mathematical model, we will find you the most efficient plan. A little bit details about this solution. They are not going to solve the problem one step. They actually solve the problem by a few steps. First, to plan the wafer. So without the subsequent stages, they only plan how to produce and when to produce the wafer productions. And after this, they will do the network capacity planning. So given the production schedule of the wafers, they then schedule the capacity of the other factories. After this step, they combine together to actually to plan the route of each orders. Because normally you want the order to go through different factories of different stages, but you want to minimize the transportation cost as well. Then how to actually transfer around all this the intermediate part so that you have the production schedule is most efficient. So over the years, Intel actually using this technology to do the design optimization as well as this production planning optimization. Over like 10 years, they achieved like 25.4 billion, either through increased revenue or cost reduction. So, which means actually this technology is really helpful in these two areas. And also, this is a use case by Intel, but for us, we also implement solutions for our customers. It's like for the LED production. You know, it's the world's most famous LED production. They have factories in Singapore and Malaysia. We have similar problems. Once they receive their orders, how to schedule their orders. And before they schedule their orders, they need to first promise, once they receive an order, can they guarantee the delivery? Sorry. Which is called the ATP, available to promise. Because their rule is, once you receive an order request, they need to respond in 48 hours to see, can we accept the order or not? Given so many orders, if you do it manually, that is almost impossible. But with this technology, we can automate this order process. Once we receive the order, then we trigger the scheduling every day, and then by the next day in the morning, then you see, how many orders can be received. And also, this is production planning. It's not yet detailed scheduling. You know, the die production, the wafer production is very complex, right? They need to go through more than 1,000 steps, the photo, the etching, the fusion, right? And they have very strict the sequence requirement, and the equipment are very expensive with the capacities. How to schedule the production of the wafers, some in the batches, some in the single wafers. Actually, we can also apply this kind of technology to do the automated production planning, scheduling of the wafer production. Actually, we help one of the customers in Singapore to implement this solution to do this, the wafer production. Okay. So basically, optimization is a technique that can help our customer to automatically generate high efficient plan or schedule. Okay. And how we collaborate with OET and Groovy. Actually, Groovy is the engine, because normally once we have mathematics, we need a solver. Groovy is a very efficient and stable solver, and we are the car maker. So with the engine itself, it cannot run. So we need to listen to your problem, we need to translate your problem into a mathematical model, and we need to implement the whole software solutions, embedding all these constraints and embedding the engine to solve the problem. So we actually have a booth outside just beside the door. So if you're interested, you can visit us at the booth. Yeah, that's all my sharing. Thank you.
Thank you, Sherwei, for your sharing. So yes, we can live on for a while if you'd like to scan the QR code or find them at the booth number 11. Cool, really a lot of takeaways during the presentation, a lot of ideas of sharing as well. Thank you once again, Sherwei, for your presentation. Okay, so last but certainly not least, we have Mr. David Chia of Backoff Automation to close out our breakout session. David Chia is Managing Director of Backoff Automation Private Limited and responsible for the region of Singapore, Indonesia, Thailand, Vietnam, and Philippines. So he will be sharing on automation technology, how emerging technologies such as smart transport system, planar movers, and modular industrial robots can propel production in the semiconductor industry towards a more efficient and sustainable future. All right, so shall we give a big hands to David? Hand over the time to you.
Mic test, mic test. Okay, it works.
Good.
And I brought my own water. Okay, I'm really the last one between you and beer. So I'm not sure whether you're sitting here because the beer haven't started or you're really interested in the topic, but to me, that doesn't matter. So I really hope to be able to share something which you may take away, and hopefully it's something useful for you. Now I have 20 minutes, but because it's the last one, I can take 30 minutes or 40 minutes until someone throw a bottle at me, then I'll stop. Okay, I'm going to talk about innovative technology for semicon and electronics industry. I'm going to talk about products, but I'm talking about how products have been adopted by users, equipment builders, into something that benefits their plant or benefits their machine. Otherwise, selling products is nothing interesting. So a bit about myself. I'm David. I take care of the operations for Backoff Automation here in Southeast Asia, having my base here in Singapore and also the other countries. I volunteer my time on the council for Singapore Manufacturing Federation. I also sit on the board for SME Center. So I work a lot with small, medium enterprises, companies in Singapore. I also spend a bit of time in the Singapore Industrial Automation Association and with OPC Foundation. Only one of them pay me, the rest are all volunteer jobs. Of course, the one who pay me is the logo that is right on top. Right? Okay, now these are components that we sell. I'm not going to go through what they are, but these are just control systems you may find in your machine if you are an equipment builder, or within the machine if you are an end user, you open up the cabinet, you may see it. Some of it doesn't make sense to you. Just like you drive a car, you don't open up to see what tire it runs. You don't really care so much. Now, Backoff, it's a German company. It's a German-based control and automation company. I show you those components that we do. We had our beginning in 1980, so this year is our 43rd year of existence. We have about 6,000 people worldwide. So it shows 5,680. By the end of this year, should be about 6,000. We do about 1.5. Probably this year we'll do about 1.8 billion. So it's a not so small SME. It's still privately owned. We have a fairly good footprint around the world, being centered out from Europe, and then we have our presence in Americas and also in Asia. Now, what we really pride ourselves in innovation. Because as a German company, there's no way we can sell anything cheap. And because we're in the semicon industry here, nothing is cheap. Only the chips, but not CE and not CHEAP. So innovations happens all the time, and we try to bring across innovations to actually our customers and say, hey, what can you do with it? Does it help you on your machine? Does it help solve certain problems? Does it help to make maybe your plant more effective, more efficient? And we actually bring this to our customers and say, please tell us what you can use it for. We are not here to tell you what you can do it or how you can do it, but let's sit down together and see how it goes. Now, if you see the light, there's no pointer here, so you have to imagine those light green color one, which is at the bottom, those are all software innovations. Towards the last 10 years, we do see a lot of innovations in the software space. The rest are all hardware innovation. Expand it a little bit, yeah, there's more products we see here. Now, I'm not going to just continue showing you pictures, I have videos. So video is more interesting, especially when this is the last session. For back off, our interaction with the semicon industry actually starts during 2000, I cannot see the slides. 2003, right? 2003 when EtherCAD was first introduced to Semi. It took a little bit of time for some companies to pick it up, and in 2007, right, EtherCAD was really adopted. Oh, thank you. The screen moves. So EtherCAD was adopted as a Semi standard in E54.20. Now, this number sounds familiar to you? Doesn't really matter. If you are an equipment builder, you probably heard about EtherCAD. Now, all top 10, top 15 equipment builder are using EtherCAD in the machine for the sensor actuator networks. They may or may not necessarily be using backoff. If all of them use backoff, I'll be very happy. But at least they are using EtherCAD. Big to small. So why do they choose technology? And when they say, hey, when we look at products and technology, when we so-called bring it to our customers, be it equipment builder or end user, we really ask, so what can you use it for? And does it really make a difference when you make a good choice of technology? So for example, Ethernet for real-time communication. So today everyone uses Ethernet. We say, hey, I just use Ethernet in my machine. It doesn't care what type of protocol it is. It faces three main sort of problems. Very classic problems. Right? First is bandwidth utilization. Do I need such a big room to contain so little people? Don't need. So this is very big bandwidth, but very few people. The rest are all outside waiting for the beer. So I don't need such a big room. Utilization problem. Stack delay is communication. How do I make up my frame? Do I need a very big frame to convey a very small message, or switch delay? Do I need switch infrastructure to do my routing, to do my star topology? Every switch you plug in is a delay. So EtherCAD actually eliminates that as a technology, and it was really being picked up from by the semi equipment builders. The earliest users is Applied Materials. It continues to be a very big user for EtherCAD. Applied and LUM, if I'm not wrong. So this is not done by back-office analysis done by another network companies on just protocols, on stack delays, running on the same piece of hardware. If you look at, these are the three common ones which is used in the real-time world. We have Profinet, Ethernet IP, and EtherCAD. Profinet, okay, 0.6 milliseconds on average. Minimum 0.54 seconds. Oh, very consistent. 0.54, 0.58. Ethernet IP cannot make it. No offense to anyone using Ethernet IP, the numbers are way off. Look at EtherCAD. Average is 0.11. This is just talking about the stack delays of implementing the protocol on a same piece of hardware done by an independent company. So choosing the correct technology can actually help in many ways. Now, I will not go into actually how these advantages can goes onto machines, but if you are talking about increase in throughput, reaction timing, yeah, you get what I mean. Now starts the video. I will show you a video of products, then I'll show you a video of how it is being used. Then I can stop talking. So what you saw are floating magnets carrying some electronics around in a free form, taking pictures, changing orientation on the move. Easily done on this system, not so easily done on conventional conveyors. Now, what did it enable? So I'm show you one of these. This is a production line on our own factory. And we test it out ourselves. We'll let the speaker talk.
Bus terminals. What this machine is all about and why we did build this machine is something which we would like to convey to you right now. But first I would like to have a short look on the motivation for us to build such a machine. Michael, the bus terminal has been introduced to the world in 1995. How did the portfolio of the bus terminal develop since then?
We added new terminals year by year. So in total today we have roughly 1,200 different variants. So about 40 different new terminals are added to the portfolio every year.
Okay, that sounds like a quite successful story. What kind of challenges do you see in 2023, 28 years after the introduction with this product portfolio?
Yeah, luckily not only the variants are rising, but also the volume we have to produce. So it's several millions of terminals that we produce. But we do not only have high runners, which we produce in hundreds, thousands a year. We also have low runners, a couple of hundreds a year. And these high mix, low volume production needs to be addressed in our production.
Okay, this means we had to rethink this topic, high mix, low volume production a little bit. And the result of this rethinking, in this case, the explanar system is linking all the different stations. So at the beginning, we have the picker, which takes the products from the trays, places them on the mover. Then we have a small camera, which identifies the serial number of the terminal. And then each of the terminals is sent to the programming stations. At the programming stations, the terminals get a specific firmware flashed on them, and afterwards it goes directly to the test station. And the system really benefits from the explanar. So the 2D movement of the explanar movers enables us to completely decouple the flow of the product. So it doesn't matter if a certain terminal needs 20 seconds in the programmer and 30 seconds in the testing station. The other ones are just driving by. Furthermore, we are also able to replace a little bit of handling system with the explanar. So the explanar system is, for example, in the testing station, handing over the terminal into the station. So what usually is done by a robot is done here with the explanar.
So some keywords, not sure whether you hear it. High mix, low volume. When we used to do this production, there are really, really high volume items which we do millions in a year. There are also some we just do a few hundreds. So when we produce it by batch, you will know that the planning is not going to be so simple. Each of these need to be burnt in and need to be tested. So now what we have is when you put up the products into the production shop floor, it reads the barcode, know what product it is, bring it to the station to be programmed, to be tested, and then, to be programmed, to be tested, and then bring it out. Which means it is actually lot size 1. I only activate the correct program I want to burn into this product when I read the barcode. I don't have to batch it anymore. Now this is just one idea of technology going into some production solution. Next, Video again. Hey, move. So these are small I/O terminals. So if you use PLCs, you would see I/O terminals, but this I/O terminal sits on PCB boards. Next is, then what does it mean? So what, I/O, everyone has I/O? Well, we have a company that does this. It's also inside the magazine. So inside the magazine, we wrote this as a story. So you see this little product that this guy is using right at the top. It gets mounted onto a machine. His product is not the machine, his product is a small little square box, and on here he has two. With that, it is an integrated controllers with I/O built in right at the bottom. So by using such a product, it enables him to design something which is really, really compact versus having a screen and then a cabinet somewhere down there to be fitted to the machine. He's able to make something extremely compact for his use. Right, try to see what he made. At first, I thought he made the whole machine. So what? No, he's actually making that small little box. So he managed to shrink his product into a small little box. Some advantages: very compact, very cost-effective for him. That's what he says, not what I say. These are pre-mounted blocks onto PCB boards. Reduce the I/O requirement space by 50%. Reduce his wiring errors because it's all pre-wired. Everything is combined into one device, and it eliminates the need for a separate PLCs. This is just one guy who say, hey, this product may be able to suit me in my application. Another implementation was on a die sorting machine. I just want to show the pictures. So where is the I/Os? Yep, it's hidden right into one of the arms. So again, these things are built in to be really, really compact in a not so small machine. So what is the advantage? Did I say? Yep. Saves around 100 hours of installation time. Plus additional time which was otherwise spent on error diagnostics and troubleshooting. So they tell us this returns their investments even from just 10 machines per year. Not too bad. Last video. I got 4 minutes. I will not use all 4.
Machine learning is now becoming a complete product family. In the year 2019 on the Hannover Fair, we introduced the products TwinCAD Machine Learning Inference Engine and also the Neural Network Inference Engine. The key aspects of this product was that we wanted to run, so the inference should take place in hard real time, in the deterministic TwinCAD real-time environment. One key aspect was also that we wanted to keep it really open. So we wanted to support the ONNX file format, that everybody could train his algorithm in his framework of choice, export this model as an ONNX file, and import this into the neural network or machine learning inference engine. So the execution of this model is hardly deterministic, and so it could be coupled with, for example, motion tasks, like you see on the presenter behind me, where we wanted to synchronize on products on a conveyor. And we wanted to make the synchronization process as smooth as possible with optimization criteria, less wear and less energy consumption. And we therefore trained a neural network to fulfill this task. Now in 2021, here we also present other products like the anti-cogging for linear motors, which also in a core uses our real-time execution of neural networks in the TwinCAD runtime. So we really take these products that we also offer to you for optimizing our own system.
Good. Because I only have the space bar. I wanted to pause it. You see the two things that look behind? Yeah, I keep looking at it. The actual one, and I was wondering, what machine learning are you trying to do over there? So when I asked him, it was him again. Then he pointed out to me, see, in the middle part, that's where we try to do the synchronizing. Yeah, that's what we do on a day-to-day basis. So what? He said, on the outer side, you see how these things return. Right, how the movers, so-called the movers, return to the conveyor. The right-hand one, the mover is returning as fast as possible. On the left-hand side one, it is returning in more slow fashion. But it is still synchronized. I say, then what does it mean? He said, from a programmer, as an engineer, when you program, you will always say, okay, once your job is done, go back, join the queue. How fast you go, I don't care. Typical SAF, run as fast as possible, go there and wait. When it's your turn, it's your turn. But it's like, hey, I don't need you until that moment you are needed, so you can actually walk slowly there. You don't need to rush there. Now, on a machine context, when you don't need to rush there, what does it mean? Or when you need to rush there, what does it mean? When you need to rush there, it is actually higher wear and tear for your mechanical equipment. So walk slowly. So long as you are there on time, it's okay. Don't walk so fast. Next is, this one creates wear and tear. It takes more energy to accelerate and decelerate. So your energy consumption also goes up. So by actually optimizing it, you can increase the lifetime by reducing your wear and tear. You can reduce your energy consumption and still meet the same thing that you want. But as a programmer, we don't think that way. Or at least as a programmer myself, I don't think that way. And if you're Singaporean, you know what the SCF will do. Rush to wait and then wait to rush. Don't do that. It will not save you energy. So these are all different aspects of technology, of products that are available, whether you are an equipment builder or an end user, that tickles your mind a little bit. Oh, can I use this on my machine? What does it solve? Help me save space, make things faster. Can I do this or can I do that? With that, I have 20 seconds. I say thank you very much.
That was quick. Thank you, David. The slides are all good? Is that okay? Okay. Right. I know David can't wait for the beer as well, right? Okay, as what David mentioned, yes, okay, if you like to look for David, his information is right in here, but I'm sure he'll still hang around at the booth area, right? All the way to 6 with us. Okay, so yes, we have come to the end of today's conference, but of course the event is not over yet. Do join us outside for more refreshments and beer, of course, and of course more networking. Yes, so the advisory clinics will be held in this ballroom, so please give us about 10 minutes time to turn over this place to become the advisory clinics, and the team will set up the clinics before it's open, so give us about 10 minutes. And not forgetting to do your part to support sustainability and claim your REC's Renewable Energy Certificates. It's for all the attenders today. So please claim your RECs before you leave, and you may approach Semcorp booth right outside if you need more assistance on that. And yes, our next event will be the Summit Conference and Singapore Semiconductor 55 Dinner in September. So we do hope you will be there with us. I'm Paige. It's a pleasure to be your MC, so we do hope to see you next time. And be back in about 10 minutes' time over here for the advisory clinic. So thank you. Enjoy yourself. Have a great evening ahead.